All right, kids. Yeah, I'll start the session. So, ask others to join as well. Anitra join in again. Yeah. So, by the way, without any further delay, let's start the session. Okay. We have the ICT what? ICT presumptions paper prepared for 2023 A levels. Like it includes what 100 MCQs, 8 structured questions, and 12 essay type questions. Yes. Yeah. Arne, let's start from structured part. So yeah, I'll make it very quick, okay? I'll make it very quick. From where should we start? Lama, shall we do memory management thing, Lama? Yeah, shall do that memory management thing. Thakal kya, Lama? Yeah, shall I do that thing? Yeah, it's real difficult. Ne? So shall I do that memory management thing? Okay, let's start from there. Yes, kids. Okay, I'll start from. Yeah, I'll start from. Yeah, now you can directly what message with me. So once again, Lamai, let's start from this question. Okay, the size of one block of a disk. Okay, like there is a disk glue. Okay, like there is a disk, and the size of one block of the disk is 8 KB. So Lamai, mm-hmm, kai dekai tunai hadarai pai hai. Okay, like so once again, kids, what is the key point? The key point is Lamai ne. There is a what? There is a disk glue. Yeah, first of all, yeah, there is a memory lama. There is a memory. So once again, like, there is a memory. You click, there is a memory, and that memory is what? It's categorized into block sizes of 8 KB. So how many blocks is now available? Like 500, 501, like 502, 503, 504, and 505. So which means like in total, Lamai, there are 6 blocks, right? So once again, Hundra Hagana Lamai, there is a particular memory, like there is a what? There's a particular memory, yeah. And Lamai, what happened? Like what have happened here is like that memory has been what categorized into block sizes of 8 KB. Okay, so it's categorized in block sizes of 8 KB. It's simple, simple as that. So Lama, yeah. So once again, if you ask me, sir, like, what about like, or else why have they started from 500? Nihimai Lama. Okay, there is a memory. Okay, like which has categorized from zero, like okay, zero in a within online, but they have just given a part of that memory. So what? That's what you should understand. So once again, they have just what they have like there is a memory which has been categorized what which has been categorized into block sizes of 8 KB, and it starts from what, and the block numbers start from yeah, and the block number starts from what 1 0 1 2, and like what they have given is like they have given the memory from what from 500 block. So that's what have happened here. Okay, so let's move to this question. What is the what is the value of the directory information at the end of this file? What is the value of the directory information at the end of the file? What is the answer, Lama? So yeah, can someone let me know? No, yeah. The diagram below shows the direct. Okay, they have given the directory entry as well. Yeah, directory entry is what, Lama? 501. So what is the like? What is the answer for the first one? No idea. No idea, kids. No, right? Okay, like I'll what? I'll do it quickly. So once again, what you should guys know is like there is a what? There is a particular memory. And what have they done is like they have categorized it into 8 kb blocks. Okay, one is other. These I'll just not categorize it very quickly. Okay, otherwise you guys will not understand. Okay, and once again, my there is what there is a memory, yeah. We can memory, yeah, a storage device, yeah, a storage what, a storage device, yeah, a storage device. And Lama, the key point is categorize what, and this is what one block. Yes, it's one block. This is one block. Mm-hmm. This is one block, Lama. And Lama, how much is the size of one block? The size of one block is how much, kids? It's what? It's four, sorry, 8 KB. Okay, the size. This is very important. Okay, the size of one freaking block is 8 KB. So yeah, let's record that as well. Nice. And Lamai, like here we have the block number. So what is meant by this, Lamai? These are block numbers. So that's what you should know. These are what? These are block numbers. Okay. So and like according to this scenario, they have given from what? They have given from 500 block, Lamai. Okay, 500 block. Next one is 500 01. Nice. Next one is what, kids? 500 what? 500 02. Then next one is 500 03. So once again, I'm hit. I don't school me, but like based on your request, only I'm doing this. Okay. 505. In a chance. So once again, Lama, yeah, these are the what? These are the block numbers given like here. Lama, metan these block numbers. Very clear. Yeah, these are what, Lama? Yeah, yeah, these are block numbers. Yeah, these are what? These are block numbers. Then if you ask me, sir, what are directory entries? So what are entries? Lama, what are entries? Can someone let me know the difference between block numbers and entries? Yes, it's like what is the freaking difference between block numbers and entries? Like now these are block numbers and what are then what the hell is what? What the hell is entries, Lama? Entries they like they specify where the next part of the file is being stored. That is the key point. So once again, according to what, according to the given scenario, my 500 के entry का मतलब like what is the entry of 500? It's what? It's 503, 501, 500. Okay. Then kids, 502, no, 504. Yeah. Mm-hmm. Okay. So these minus one. So it's very clear. So once again, kiddos, like these are entries, okay? Kids, what are these things? These are entries. So if you ask me, sir, what are entries? Like if you ask me, so what the hell is entries? Okay, I'll explain it to you, kids. What are entries? Okay, what are entries? They point out these are what, kids? These are entries. They point out where the next part of the file is being stored. Yes, Lama, yeah. So what are entries? Like they specify where they specify Lamai, where the next part, where the what, kids, where the next part of the file is being stored. Yes, like what are entries can I like they specify where the next part of the file is being stored. Then the keyword, like what is the keyword? Directory entry. What is what? What is directory entry, Lamai? Can someone give me a nice definition for directory entry? Any volunteer who can give me a perfect definition for directory entry? Anyone? Yes. Can someone give me a nice definition for directory entry? Yes, kids. What the hell is directory entry? Please do make it quick. Yeah, what is directory entry, Ramaini? Can someone make it very quick? What is directory entry? It is the block num. It is the what? It is the block number. No, it's okay. Like no, it is the block number. No, it is the block number in which the first first part of the file is being stored. Lamai, what is directory entry? Directory entry can it's what it is the block number in which the first part of the file is being stored. So according to this scenario, like they have not given the name of the file. Look, like let's assume it's what Let's assume it's bright tech file. Okay, mandanna make a edit, but it's nice name. Okay. Okay, like there is a file called, yeah, there's a text file called bright tech. Okay. So once again, kids, yeah, okay, there is what file called bright tech. And Lamai, what is the direction of this file? It's 500 and what? It's 501 Lamai. So once again, what is direction? It is the block number in which the first part of the file is being stored. So once again, what is direction? It is what? It is the entry where the first part of the, it is the block number in which the first part of the file is being stored. Which means, Lamai, first part of the file is being stored where in which block? 501. Aha. This is where the first part of the file is being stored. Koma dekha. Sapai neda. Then Lamai, then in this block there is an entry called 500. What is meant by that? 500 specifies where the next part of the file is being stored. Okay, like yeah, specifies. Yeah, nothing. Specifies the block number. It like it's they specify the block number where the next part of the file is being stored. Like they specify the block number where the next part of the file is being stored. Lama. So once again, what is like okay, it's five. The entry is 500, which means the next part of the file is being stored in 500 block. Okay, interesting, right? Yes, interesting. Isn't it easy, Lama? So these things like when it comes to this file allocation table, a lot of students are telling it's difficult. I what I find like make I find it very interesting as well as easy as well as make a part simple yeah. It's part simple. Or so we okay. So let's move to 500 block llama. Okay, like the next part of the file is being stored in the 500 block. And what? And in 500 block llama, what is the entry? 503. So what is specified in entry? They specify the block number where the next part of the file is being stored. Okay, which means the next part of the file is being stored in the which means the third part of the file is being stored where llama. The third part of the file is being stored in 500 and what? 503. Okay. So in 503, what is the entry? 504. Like what is meant by 504? It's an entry name. It specifies the block number where the next part of the file is being stored. Where is the next part of the file is being stored? Okay, in the what? 504th block. So in the 504th block, Lamai, there is what? There's an like entry. The entry is what? -1. Lamai. What is indicated by -1? This entry indicates what? End of the file. -1, -1 is the what? Is the entry which indicates the end of the file. Hope it's very clear. Yes, Lamai, -1 is the entry which indicates the end of the file. So hope it's very clear. Lamai, cannot rem yeah. Is it very clear? So which means like this file is categorized like this file is not like make a gediya pitting in stoke run. You want what? Like at once to this bright text file what happens is this bright text file is categorized into like four pieces like and first part okay what about the first part of this file it's stored where kids it's stored in 500 block okay it's stored in the what 500 block so what about the second part lamai the second part of the file is being stored in where sorry, first part is 501. Sorry, first part is what kids? Sorry, first part is 501, and second part is what? Second part is stored in 500, and third part is stored where kids? Third part is stored in 503. Nice, nice, nice. Okay, 503. And what about the last part of this file? The last freaking part of this file, or is the fourth part? The last part is stored in 504. Are you guys clear with this? Like, this is the what? This is the last part. This is the first part. Okay. So hope it's very clear, Lama. All right. So was it very clear, kids? Like, did you all understood this? So once again, Lama, yeah, -1, yeah, the -1 is the entry which indicates the what? End of the file. Not the, yeah, it indicates, or as you can write, it indicates the block number of the what? The, yeah, just yeah. It's clear. Don't make, like, let's not make it more complex. So was it very clear? I want a response, Lamaini. So once again, yeah, I want a response. Was it very clear? So once again, what is directory entry? Directory entry can the directory entry means Lama, it is the block. Like it is the block number in which the first part of the file is being stored. According to this scenario, the directory entry is 501. So like which means the first part of bright text file is stored in 501st block number. So yeah, you go to 500 first block number, there only the first part of the file is being stored, and in block there's an entry of 500. What is meant by that? What is meant by 500? So which means like, okay, the first part of the file is being stored in 501. What about the next part? Okay, the next part is stored in 500 block. That is what is indicated by this number. These are entries. Entries can, like, they specify the block number where the next part of the file is being stored. Then you go to 500 block number and you what, read the next part of, like, the second part of the file, and yeah, you need to go to the third part. So where is third part stored? In the 500 third block. Okay, you go to 503rd block, and yeah, you read the third part, and after that you need to read the fourth part. So like you move to 504. Okay, yeah, you read then yeah, you go to 504 and read the fourth part, and yeah, and in this block there is an entry called what, -1. What is indicated by -1? -1 indicates the end of the file. Shaka boom, the file is over. Happy ending. Right end, yeah. Happy or bad, that is the ending. -1 indicates the ending. I don't know whether it's a happy ending or bad ending. Anyway, yeah, it's -1 indicates the end of the file. Was it very clear? Hope, yeah, was it very clear? I want responses. Yes, right? What is the value of the directory information at the end of the file? Yeah, what is the like what is the value of directory information? It's minus what entry indicates the end of the file? It's minus what? What entry? What entry indicates the what? End of the file? -1. They ask, what is the value of the directory information at the end of this file? Yeah, what is the final one? It's minus. It's -1. Usually, yeah, usually like examine like up to today, they have asked the what, directory entry. So in this question, they have what, asked them a final directory information, which means like the final one is what, -1. Was it very clear? Very clear. The matter. I think it's clear, right? So if someone asks you like the capacity of bright text file, I mean, now the file, what is the yeah, can someone let me know the capacity of bright text file? Yes, can someone make it very quick? The capacity of bright text file, make it quick. What is the freaking size of bright text file, man? What is it? So like we have utilized 4 blocks in Lamai, and how much is the capacity of one block? It's 8 KB, which means 8 KB multiplied by 4 blocks. The answer will be 32 freaking what? KB, right? Am I correct, Lamai? 8 KB multiplied by 4. The answer is 32 freaking KB. The size of bright tick text file, it's 32 KB. No, it's not 8 KB. 8 KB represents the size of a block number. And we have utilized 4 blocks, which means like the size will be 32 freaking KB. Was it very clear? Yes or no? Yeah, it's clear. කොච්චර කියනවත් වැඩ ළමයි, when you're writing your like A-level examination, please what? Please like carefully what? Write the answers, okay? Like අදත් මට ළමෙක් හම්බ වුණා මං කිව්වා දෙකක් කිව්වා යාට දන්න ආන්සර් එකක් වරද්දලා තිබ්බා like that binary conversion. මාස් මම පැලෙන්න දෙන්න තියෙනවා. හරි. Yeah, like no, like no, it's that's the block number. That's the block number. They're asking what is the directory information. It's mine. Like what is the value of the directory information? Yeah, that's what they're asking. So it's minus. All right. Up yang ini. So how, yeah, how 32 KB. So Lamai, like one yeah, we have utilized 4 blocks of this memory, and one block represent 8 KB. So it multiplied by 4 and is 32. Hope it's very clear. Next one. The size of the file is increased by 16 KB after editing. Okay, now I'm editing bright text txt. Okay, I'm editing this file. And what happened is, like the file size is increased by what? 16 KB. Okay, which means another how many blocks should I use, Lamai? Yeah, like another how many blocks should I use? another two blocks should be used, right? Then what are the changes that need to be what done? Yeah, that should be made in the FAT using the given blocks only. Nice question, nice question. So once again, kids, what happened is like I'm what I'm gonna expand this file now. Okay, I'm gonna expand this file and the what size of this expand current amount is size the size of the expanded amount is 16 KB. Nice, it's 16 KB, which means like we need to use what uh, two 8 KB blocks. Okay, like which means like we have fifth part of the file. Okay, fifth part of the file, and we have what something called sixth part of the file. So hope it's clear. Okay, and sixth part becomes the what last one. Yeah. Okay. Yeah. Easy. 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 This is not the last one. This becomes the last one. And okay, so what to do, Lamai? What to do? Now what to do? Yeah, Naban. Yeah. So like what to do, Lamai? So once again, you should what? First of all, listen to this very carefully. So once again, kids, okay, what to do now? Yeah, yeah, the last block which stores the above information, like Lama, in other words, like may file like what is the last block which stores this file? The last block which stores this file is 504. Like five in 504 block, only the last part. Like at the moment, the last part of the file is being stored in 504th block. And now my what is the entry of that block? It's -1, and which indicates the end of the file. Now, due to an addition, Lama, now this is not the end of the file. This is not the end of the file. So then, okay, let's assume the next part of the file is being stored in 505. The next part of, yeah, or else the fifth part of the block is stored in 505. So if it's 505, in the full, like in the earlier block or a fourth part of block, you should what? You should make the entry as how much, Lamaine? 505, and you go to 505. And in 505, what stored Lamai, the fifth part of the block is stored in the 500 like, fifth block. And what about the sixth part? Okay, like according to the given scenario, like there is only another block which is 502. Okay, let's utilize what? 502. Okay, create the entry as 502 and store the last part of the block, like the sixth part of the block, the last part of the sixth part in 502nd block. And in that block, what would be the entry? The entry will be freaking -1. Was it very clear? So like the last part is stored where in 502nd block, and the entry of 502nd block is made to -1. Was it very clear, kids? So if someone wants to use 502nd block into, like for example, like if someone wants to store the fifth part in 502nd block, okay, no issue. You can store the up. That's not an issue. According to me, I'm what? I'm storing the fifth part of the block where in 500 and like 500 and what? Fifth block, which means fourth block I put it as what 505 and store the fifth part in 505, and I what store the sixth part in 502. So I made this entry 502, and yeah, in 500, like 502nd block number, the entry I mark it as -1 because that is the end of the block. So if someone is not willing to store the fifth part in 502, okay, what should happen is like fourth part, okay, yeah, go to the end of the fourth part and make it 502 and store the fifth part in 502. And in that block, you can enter the entry as what 505. And the last part you can store in 505 and indicate here -1. That's up to you, kids. And that answer is also correct. But you should what? Write the entries and block numbers correctly, okay? But yeah, you can do in this like in this method as well as that method. That method. That's not an issue. Like so, according to me, Lama, the fifth part is yeah. Where do I store the fifth part, Lama? In 505th block. So I will move to the what? Block number where the fourth part is stored, which is 504. And in that block, I changed the entry as what? 505. Okay, then yeah, the fifth part is stored in 505. And what about the last part? Then I am left with no other option. I should store the last part in 502, which means I should make this entry 502. Okay, then go to 502. That yeah, the last part will be available, the sixth part. And yeah, since since it's the last part of the file, what will be the entry? Minus freaking -1. Was it very clear? Kerala man. So if you ask me, say, like how to write it, okay, you can write it something like this. Yeah. Change what? Change. You can write it something like this. Okay. There are some series of steps to be followed. Okay. I'll just let you all know. First of all, change. Okay. Yeah. Change the entry of block number. Change the entry of block number 504. Change the entry what? Uh, from what? From yeah, from -1 to how much is it? My 500 and 505. Okay, change the what? Entry from -1 to 505 in yeah of what? Of block number 504. Then go to what? Then then what happens? Yeah, insert the entry, the entry, the what? The entry of block number, the entry of block number 505 as what is it, Lama? What is the entry? 500 and 502. Okay. Then final. Then what? Then insert the entry of block number 502 as how much, Lama? -1. So like why -1? Because in what? In 502nd only the last part of the block is being stored. Well, the unknown, like that part is not required, but you should write these things, Lama. These are the what? These are the changes you need to make. So was it very clear? Was it very clear, kids? Up to this point, first of all, what happens? Change the what? Change the entry of 504th block from -1 to 505. Then go to 505th block number. And there insert the entry as 502. Then go to 502nd block number. Insert what? The entry there as -1. Was it very clear? I think it's clear, right? Kids, I want a response. Tagala, make it quick. Make it quick. Pius. Yes, right? Yeah, I think it's clear. Nice. And thank you. Yes. The screen is blur. Lama, is the screen blur, Lama? Is it blur? Like, is it blurred? Blur will nothing is visible? Just a second. Just what about now, Lama? Now, what about now? Is it blurred now? Hmm. Okay. So yeah, just give me a second. Maybe. Just give me a second. Just give me a second. I have an option for you. I'll just take a screenshot of this. I'll just take a screenshot of this. And I'll just stop the share. What about now, kids? Is it still like, is it still not visible? Still same? Kids, can someone confirm it to me? Yeah. Is it still the same? Like, is it like still blurred? Yeah. Now okay, right? Thank you. Thank you, kids. Thank you. I'm sorry for the inconvenience, okay? Okay, yeah. Now is this one visible? Yes, right? So I took a screenshot. This was what like now is it visible? Yes, right? Beta means now it's so yeah. RNA? Now no issue, right? Okay. Nice. Still again blur. Is that the problem? Circle, not this one. No, it's not the connection to get distance. Now, yeah, what about now, kids? It's okay, right? Harne? Now, is this screen visible? Is this one visible? Yeah, I'm displaying a screenshot. Is it visible now? I'm displaying a screenshot. Is it? Okay. Menna tiyena, yeah. Yes, right? Okay, good, good, good. So, yeah, yeah, take a screenshot, take a screenshot. So, like, was it very clear? So, what happens? Let me change it on. Change the entry from -1. Yeah, change the entry from -1 to 505 in what? 504th block. Then go to what? Go to 505th block and change the entry there. Change means like just insert the entry as 502. Then go to 502nd block. Like, which is the last part? Like, which is the block number which stores the last part of the file. And yeah, they insert the block as what? They insert the block as sorry, they are insert the entry as -1. So, yeah, all good and all clear. Takal kyan? Yeah, all good and all clear. So let's move to next one. Let's move on to next one. Apa yang ini? Part C. Okay, let's move to this. Okay, before that, let me put a list. Put a kapnya. Let me shall we move to this logic? Sorry, networking thing. Yeah, shall I do the networking thing? I'll do the networking thing and come to what? This question. Yeah. Yes, yes, yes. So let's move to networking. Lamai networking might be easy. Okay, hagan lamai. Yeah. Once again, lamai networking what? Networking might be easy, but lamai you might what make some mistakes. So product hagan. There are two networking questions. Okay, I'll do this networking question. So once again, lamai Crawford University has what? Has five separate buildings of medicine, engineering, management, law, and information technology. The management has decided what? Set up computer labs consists of 20, 25, 28, 10 and what? 10 and 26 computers for each faculty respectively. Okay. And the faculty of information technology will provide internet connectivity through what? Through common IP address category 192.168.10.0/24 to other faculties through and what? Through internet service provider. Okay, no issues. Okay, there's a network printer has been allocated. Blah blah. All those things. Yeah, like, let's start this sheet. Okay, let's start this sheet. Alright. So once again, kids, on a so they have given the IP address. What is the IP address, Ramai? The IP address is 192 dot. The IP address is 192.168 dot 10.10.0. Okay, this is the what? This is the IP address. This is the IP address. Okay, this is the IP address. Okay, /24. Lama, if it's /24, what is meant by /24? /24 means the above IP address is available in CIDR notation. What is CIDR notation? Classless interdomain routing. Once again, Lama, if that /24, /25, 26, so whatever is available, the what? This update mask is available in CIDR notation. Classless interdomain routing. So, Lama, and what is meant by this what? 24, Lama, 24 means like they are a what? They are 24 network bits, like there are what? 24 network bits or ones in subnet mask. So that is what is meant by what? That is what is meant by minus. Sorry, that is what is meant by 24 lamai. So once again, what is meant by 24? 24 means there are 24 network bits or as ones in subnet mask. So once again, write the subnet mask lamai. So you can write it like this. I'll make it very quick. Mhm, mhm. 24, yeah, 24 ones will be available. So, Lamai, can someone let me know, Lamai, what is indicated by subnet mask? Like, actually, what is indicated by subnet mask? Lamai, subnet mask always indicates the size of a network. Subnet mask always indicates what, kids? The size of a network. So, once again, these ones are known as what? The ones are named known as network bits. Okay, like they are known as what, kids? Network bits. Network bits means the bits used to create the networks. Yes, or as what, number of ones. Okay, I'll just make very quick. Yeah, number of ones. Okay, which is what, which is 24. And now please, yeah, note down all these things. Okay, so once again, what are networking? So like number of ones, and that is what, 24. And like, what about like these zeros? Lamai, zeros means what? Number of what? Number of maybe or else, yeah, hospitals. So number of zeros. Lamai, yeah, number of zeros. Number of what, kids? Number of zeros. Nice, nice. Yeah. So which means, kids, yeah, which means, so once again, yeah, up to this point, clear, Nelamai? Is it blur once again, the screen? Yeah, is it blur? No, right? Hope it's not. Hope it's not. No need. Is it blur? Alright. So once again, Lamai, hospits kiya. Yes means blur the. So once again, yeah, I'll just got mark. Alright. So once again, Lamai, I'll just one tackle here and then season. So hospits can, yeah, what is hospits, Lamai? Number of zeros. So like how many zeros are available in this, like in these scenario, Lama? In this scenario, yeah, there are 8 hospits. There are 8 hospits. So which means, yeah, 8 hospits can 2 to the power 8. And Lamai, once again, Dagan, hospits indicates, Lamai, hospits indicates the number of addresses available in a network. Once again, Dagan, hospits indicates the number of addresses available in a what? In a network. So once again, what is indicated by hospits? Hospit indicates the number of addresses available in a network. So once again, yeah, 2 to the power 8 means there are 256 addresses in this what? In this network, which means the what? Which means, Lamai, this so-called university has how many addresses, Lamai? This what? This so-called university has, Lamai, 256 addresses. This so-called university has how many addresses, Lamai? This so-called university has 256 addresses. Hope it's very clear. So once again, yeah, slash 20. Yeah, once again, what is slash 24? Slash 24 means number of what? Number of slash 24 means number of network bits in the what? Subnet mask. So network bits, subnet mask and network bits 24 lamai, which means the host bits are how much? Host bits are like no need to teach this thing lamai. When it comes to IP address, yeah, we are talking about IP address version 4. IP address version 4 contains 32 bits. Okay, it contains 32 bits. IP address version 6 contains 128 bits. So once again, when it comes to IP address version 24 bits, if the number of ones are 24 lamai, how much is the number of zeros? It's 8. So once again, zeros means host bits. They indicate the size of the net. I mean, like, yeah, the size or the number of addresses available in a network. So it's 8. So which means 2 to the power 8 means how many addresses are available in this what? In this university, there are 200 and what? There are 256 addresses, and that 256 addresses, only need to be what? Divided among these what? 5 separate buildings, which is medicine, engineering, management, law, and what? Law and IT. So once again, kids, yeah. So there's a small shortcut to do this. Okay, what is the shortcut, kids? Yeah, you can just draw a circle. Okay, like you can just what? Just my this shortcut will what? Save your time. Okay, there is a small shortcut. So is this variable length subnet mask? Yeah, according to the scenario, like according to the scenario, I think variable length subnet mask is only like even you can do it in fixed length subnet masking. That's not an issue. Fix karat variable as prashne. That's not an issue. You can, yeah, you can do whatever the method you want. Do Now I don't try to memorize these things. Man, don't try to memorize these things. Like you can what? You can do it in variable length subnet masking as well as fixed length subnet masking. No, they who like him and in A level question, no, they are not asking like to doing what? Variable length, fixed length. No, it's not. Him, yeah, you cannot do it in the method you want, Lama. Yeah. In A levels, no, they don't ask. In which year? In which year? So once again, yeah, in which year they asked? No, yeah. So once again, it depends on the question. Like, like if they what, if they ask you to do in variable and subnet masking, yeah, uh, which means the question cannot be done in fixed and subnet masking. Like, that's the exact reason they what ask you to do it in variable and subnet masking. Anyway, like let's come here, Lama. Let's come here. So let's come here. So according to this scenario, Lama, you have got 256 addresses, and Lama, you should divide it among how many departments? You should divide it among five departments. Okay, like there are five departments. First of all, let's divide these addresses equal into two, Lama, which like if you did, yeah, if you div on once again Hagan, so in this what this university has 256 addresses, okay, and they need to be divided among these what these university like these faculties, Lama. Then what about the number of computers they have? 20 what 25, 28, 10, and what 26, yeah. So yeah, let's first of all divide this 256 equal into 2 lemma, which means one side will have how much? 128, right? Yeah. One side will be having 128, but it's not enough. You should divide it among five departments. Okay, now you are you categorize it to what? Yeah, four segments, lemma. Which means yeah, how much is it? One segment will be 64, 64, 64, and yeah, and 64, right? Yes. Yes. But still we are not done. Still we are not done. Still we are not done. Like, okay, like first of all, we divide into what? Two, then yeah, we are now divided into what? Four sectors, but there are how many departments? Five departments. Okay, now what you should do is just take what? Take one of these departments and redivide. Okay, yeah, you can just what redivide it. You can just what? Redivide it. So which makes it what? 32, and this one also has 32. So once again, kids, what happened? So what happened? Yeah, Kiana Balan. So what happened was, Lama, yeah, you had 256 addresses. So you equally divided it first of all. Okay, like equally divide karam, what happens? So 128, 128, and still it's not enough. You need to divide it among what? Five departments. So what happens is you divide it among four, Lama. Like, four na 64. Okay, 64, 64, 64, and 64. And now five departments, Lama. So redivide what? That 64, one of the 64 segments into two, Lama, which makes it 32 and third. Now it's all okay. Now it's all okay. 64, 64, 64, 32, and 32 now. Hope it's very clear. Hope it's very clear. Yeah. Hope it's very clear. Just, in still it's blurred the lama. Still it is blurred. I'll just yeah. Camera now okay. Now okay, right? Now okay. Yeah, I'm recording to YouTube. Yes. Now okay, right? Now no issues, ne? Yeah, okay, okay, nice, Lama, okay. So once again, sorry for the inconvenience. Okay, 64, 64, 65, and H 32 and 32. Yes, 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 64, 64, 64, 32, 32. So was it very clear, Lama? Was it very clear? So what happened? Like we had what? We had 256 addresses, and yeah, we had 256 addresses. So like first of all, it's divided equally among like four, Lama. When you then Lama, one segment will receive 64 addresses. Okay, 64, 64, 64, and 64. But it's not enough, Nilama. We have five faculties, so which means redivide that 160.2, which makes it what? 32 and 32. Now, this is variable in subnet masking. This is variable in subnet masking. So like why is it variable length of subnet masking? Because some departments are getting 64 addresses, some departments are getting what? 32 addresses. Simple dilemma. Yeah. So like so yeah. Another student can divide it like this as like කටපාඩම් කරපු ළමයට මෙහෙම කරන්නත් පුළුවන් ළමයි. I'm not scolding anyone, but like කටපාඩම් කරපු ළමයට මෙහෙම කරන්න පුළුවන්. Okay, like what you can do is okay. You can what? Just take 256 addresses and you can what? First of all divide it like divide into four. Then one segment will have what? 65 addresses. Ne? Then once again, yeah, divide all the segments into what? 8. අටකට බෙදන්න ළමයි. Just what? Divide into 8. If you divide into 8, what happens? One segment will receive 32, right? Yeah, one segment will receive 32. But like according to my personal opinion, okay, like according to my personal opinion, Lamai, dividing like this is what? It's a waste, Lamai. It's a waste. Why is it? Why am I saying so? Like according to this scenario, what has happened is Lamai, 256 addresses are divided into what? 8 subnets, Lamai. Now you have only 5 subnets. So in the like in a university there is only what 5 faculties. Why the hell are you creating subnets for 8 faculties? Like why Muna? How are Lamaru gonna him? I mean like if you are yeah these are things which happens in the practical world. So if you become network administrators, you guys should go to what organizations and you should divide it like this and just think Lamai, I'm the dean of the what university and I'm telling okay Mr. So and so you are the network administrator and we have received an IP address which consists of 256 addresses. So can yeah we have 5 faculties and can you what please allocate those 256 addresses among those 5 faculties. And what you guys do is like you create 8 subnets and the size of each subnet will be 32. Prashna, no issue. It's 32. But like when I come there, like I'll be like, what the hell have you done? So I'll definitely scold that bugger. Why is it like in this company or in this university we have only 5 faculties? So why the hell did you create what 8 faculties? But so I'll simply ask you are මොනවාද මේ faculty තුනක් හවරෙන් හදනවද? That's what I'll ask Lamai. Like no point. So that's how you identify whether it's what fixed length or variable length. Like, this is fixed like this is what this is FLSM like fixed length subnet masking. So like what is fixed length subnet masking? If the size of each subnet is equal, that is fixed length subnet masking. Yeah, it's equal. Like there are 8 subnets, and out of this, 5 will be given to what? 5 will be given to these 5 faculties, and yeah, and the size of each faculty is 32. And no issues. That's fixed length. But this is variable length. Why is it? Because 3 faculties will get 65 addresses and 2 faculties will get only what? 32. But the advantage here is we have utilized all the what? All the 256 addresses. And Lamai, like just assume like we need to what? Medicine, yeah, we need to increase the number of computers in medicine faculty to 40 Lamai. Now no issues. You can increase it because like you can allocate 65 addresses to medicine, yeah. And yeah, which means yeah, you can increase it to up to 62, you can increase the if there is a requirement to increase the what number of computers in faculty using this method is pathological now. Was it very clear? So like those things are not the yeah, not huge things now. Clear, right? Kiddos, yes, make it quick. I all done. Like was it very clear? So anyway, Lama, according to like areas, you can do it in both methods. They won't like make yeah, they won't what? They won't cut your marks, like they'll what? Give marks, okay, that's not an issue. Lama, did you all understood it? Like, was it very clear? Yes or no? Yes, right? So I'll go with the what practical method. Okay, I'll go with the what? I'll go with the practical method. Yes, I'll go with the practical method. And Lama, yeah, what happened? We had 256 addresses, and yeah, like I divided it equally among 4, and one department gets 64. And what happens was like now we need to create 5 subnets. Lama, so one subnet was redivided to 32 and 32. And yeah, now we have 5 freaking subnets. And let's find the subnet mask of like these subnets now. And yeah, nam tikat dagana. So first faculty is what lamine medicine faculty. We like give 64 to medical faculty. Yes, one of my favorite faculties lamine. Yeah, medicine faculty. Just give 65 to medical faculty and engineering faculty. Yeah, not that much of fond of engineering faculty. Yes, give 64. And what happens, okay, like then let's come to management. Yeah, go beauty in all the what? All the GOP are available in management faculty. I mean, in Columbus. No, no, it's not like that. But anyway, funny people are available in management faculty. Okay, let's move on to law faculty. Okay, the real vendors are available in Valamai, Colombo law faculty. Okay, let's move on to what? UCSC, like IT faculty. Yes, all the posh people are available in this what? In this faculty. Lama. Yeah, yeah. This is what? This is simply what Colombo University medical faculty. What happens? Like the real vendors. What? Real vendors means like Pandita in medical faculty. So engineering lamai ඕනේ ඉන්න අය මැනේජ්මන්ට් ආතල් IT පොෂ් අය ලෝයල රියල් වැඩ්ඩු හරි yes nice it's nice let's go it came out nice and once again yeah, you need to what you need to find the මේ ඔන්න බලන්න so once again yeah you need to what you need to find the size of each like or else you need to what find the subnet mask of each subnet ළමයි so what you should do is okay there is a shortcut, okay? Like when it comes to medical engineering and management faculties, how much is the size of it, Lamai? So once again, when it comes to what? When it comes to medical engineering and management faculty, how much is the size of it? 64, right? So Lamai, when it comes to subnet mask, like the size is indicated by zeros, ne? So which means 64 means Lamai 2 to the power how much? 2 to the power? Is it 2 to the power 6? Yes, right. Which means in the subnet mask, there should be 6 zeros. So yeah, you create the what? You create the subnet mask. You create karanna. But last 6 zero, like 6 bits should be zero. So this will be the what? This will be the subnet mask of what lamai? Medicine, engineering, and management faculty. So once again, this will be the what? This will be the subnet mask of medicine, engineering, and management lemma. So how did I calculate it? So just get the size of these faculties, which is 64, and in a subnet mask lemma, zeros indicates the size of a network. Ne? So which means 64 can 2 to the power 6, which means in the subnet mask there should be like the last 6 bits should be zero. So like just make the last 6 bits zero and the remaining things as one lemma, and just convert it to what? Dotted decimal notation, please 255, and yeah, last one is 192. Was it very clear? Kids? This is the subnet mask of medical, engineering, and what lamai management faculties. Yes, so no. Yeah, you can consider from that side as well. Yes, yes. And in some Christians, Lama, they'll ask how many network bits are used here, like or else like they'll ask how many what how many host bits are used to create the networks. Yeah, they'll ask a question like that. How many host bits are used to create the networks till high? So according to this scenario, it's two Lama. Maybe like we had 8 host bits, and now we have only how many host bits? 6 hospits, which means we have used 2 hospits to create these networks. So that is something out of the what out of this question. Okay, now let's move to low and IT. Lamine. In low and IT, the size of each faculty is 32 Lamine. 32 means how much Lamine? Like 2 to the power how much? It's 2 to the power. It's 2 to the power 5, right? Which means once again in a subnet mask, like zero, so once indicates the size of a subnet mask, the zeros in Lama, which means there should be what? How many zeros? There should be like in the subnet mask, there should be like at the end of the day, like there should be 5 zeros, ne? And the remaining thing will be one. Okay. It's simple as that, Lama. Alright. So just write it like this and convert to dotted decimal notation to yeah 255, 255, 255. 224. Yes, yes, yes. Yes. Yeah. According to 64, 32. Yeah. 32 or 64. Yeah, you can't. Chemical is done by. Was it very clear? The way I took the subnet mask of low and IT as well as what? Medicine, engineering, and management separate. Was it very clear? So, like in this scenario, to what? To create like low and IT lamai, we have used how many hospits? 3 hospits. And in the question, like commonly if they ask how many hospits have been used to create the networks, yeah, right as what lamani 3. Why is it like max? Anyway, yeah, at the end of the day, maximum they have used 3. So we had 8 hospits, and now we have only what? three, sorry, yeah, 5 house bits, which means we have used three. Huh. So what is the difference between usable IP address and valid IP address? There is no difference. Same. So so now, how did you divide it into? So, so yeah, like just think this as a piece of like a round cake. Calculate that. Okay, just think it as a cake, and the capacity of the cake is how much? The capacity of the cake is 256. So first of all, you divide the cake into two, and like, is it enough? No, like here we need to divide the cake into five pieces. Like here we need to divide the cake into five pieces. Okay, like when you divide the cake into one side will be 1 to 8 and other side will be 1 to 8. But it's not enough. You should divide into five pieces. So like okay, now what has happened? That you have divided the cake into what, four pieces, but it's not enough. You need to divide it into six pieces. Then take one of the like four divided pieces and re-divide it. So now you have what, divided the cake into six pieces. And how much will be the size? This will be 64 kg. This will be 64 kg. This will be 64 kg. And here 64 kg was re-divided and one will be 32. Was it very clear? Yeah. Was it very clear? Hmm. Yeah, yeah. It's clear, right? Simple and like learn ID like that, Lama. Look, just assume this as a pace like a round cake, Lama. And then yeah, divide it like how for example, like here what? Here they are asking to divide it among five faculties, which means like always, yeah, always find the number of addresses available in that university or business and find how, like, to how many faculties or like departments we should categorize and just divide it. Like, if it's what, if it's six, Lama, yeah, first of all, divide into four and like, uh, two of those what subnets should be re-divided. Okay, now you have what? Six. If it's seven, yeah, divide it like this. If it's eight, okay, divide it like this. If it's nine, divide one of the things once again. I mean, was it clear? That's how you do it. It's not the There's no rocket science here. And then how to find the what? Then how to find the subnet of like, how to find the subnet mask of each subnet? Just identify the size of the subnet and size is indicated by zero. And yeah, like if the size is 64, it's 2 to the power 6, which means the last zeros should be last six bits should be zeros, the remaining things should be ones. And if the size is what, 32, once again it's 2 to the power 5, the last five bits should be zero and the remaining like things should be ones now. It's very simple. It's like there is no rocket science here. Please, like, don't make it what, like, don't, or else like think it as what, rocket science with an amount of the if it's difficult, I'll tell you, it's difficult. Okay, memory management, it's difficult. But this is not it. And yeah, all am I? It's 255, 255, 255, what, 224. Okay, nice, nice. It's done. It's done. So now let's move to this. Lamai, let's move to this scenario. So yeah, they're asking medical faculties network address. Network address can Lamai the first address of a network which cannot be used. Okay, so let's start from here, Lamai. Let's start from where? Okay, 19. I'll just yeah. First take it. Okay, 192, 168. 10 dot. Okay, you start from zero. You start from how much now? Start from zero, and broadcast address means the last IP address of a network which cannot be once again used. Okay. So like yeah, after the network address number, you have the like the first usable address. So what is the first usable address? It's one llama. 192.168.10.1. So which means like if you ask me, so how to find the last usable address here, it's difficult to find the last usable address, but you can find the broadcast address llama. Broadcast address will be what? 63. Why is it the size of medical is how much now? The size or the number of addresses given to medical faculty is 64. And the first address is 0, which means Lamai, the last address should end from 63 because it started from 0 only, and which means the what? First usable one will be 1 and last usable one will be 62. Like these things are very simple, right? You guys have had done it, simple. Yeah, and what is the subnet mask? It's 225, 225, 225, 225. One last one is 192, right? So good. Let's move to next one, Lama. Let's move to engineering faculty. So what about engineering faculty? In engineering faculty also, Lama, there are only 64 addresses. Okay, there are nothing else. There are only 64 addresses. So and the previous, yeah, So the yeah, previous faculty is ending at 63, which means this one starts from 64. And like, what is the first usable one? The first usable one will be 65. And how to find the last usable one, Lama? There's a shortcut. There's a shortcut. So you go to the what? You go to the previous last usable ID, which is 62, and add what? Add the size of the current subnet, Lama. What is the size of the current subnet, Lama? 64. Ne? Just add 64 to 62, which makes it what? 126, right? Yeah, then how much is the broadcast ID? 127. Hope it's very clear. And the subnet mask is 255, 255. Last one is 192. Hope it's very clear. Once again, Lamai, was it very clear? Yes, right? So yeah, how 126? So like, how to find the last usable IP address? Take the last usable IP address of the previous one, which is 62, and at the size of the current network, engineering is size is 64, 60, like, then 62 plus 64, it's 126. Was it very clear? I think yes. It's clear, right? So let's move to next one, kiddos. Okay, let's move to management. Okay, let's move to management faculty. And yeah, engineering faculty is ending at 127 element, which means this one will start from 128, and you can't use the network address, which means the first usable address will be 129. And once again, kids, how to find the last usable ID, Lamine? Check the last usable ID of the previous subnet, which is 126, and add the what? Size of the current subnet, which is also 64. So 126 plus 64, what is the answer? It's 190, right? And like, then like, what is the broadcast ID? Broadcast ID is 191. So what is broadcast ID? It is the last usable, sorry, it is the last address of a network which cannot be used. Nice. So let's move to Lola, my favorite faculty. So what is like, management is ending at 191, which means low is starting from 192. What is the first usable address, Lama? It's 193. And how to find the last usable address, Lama? You take the what? Last usable of previous subnet and add the size of the current network. Loika podi, Lama, loika 32, which means that 32 to what? 32 to 190. This becomes 222, Lama. And the last, like the broadcast will be 223, and which means IT will start from 220 what, Lama? 224. Yes, nice. And once again, Lama, yeah, the subnet mask of this one is 92, but low it's 224. Low is subnet mask is 224. IT also it's 224. Yes, nice. Lama, this started from 220 what? 4. And first usable one will become 225. And how to find the last usable? Just add what? The size of this one, which is 32. 32 plus 222. What is the answer? 254. And what happens to the last, like, broadcaster? It's 255. Nice, Nenamai. Nice. You started from 0 and you should end from 255. Why is it? Because there are only 256 addresses in this what? In this freaking university. This university has 256 addresses. Then Balana could, like, we have nicely divided it. What? We have nicely utilized this entire 256 addresses and divided among it 5 departments. Was it very clear? Yes, right? Clear than at the කියන කාදාගන්න. නෑ මේක තේරුණානේ නේද? ප්‍රශ්නයක් නෑනේ. Are we done? Done නම් ඉතින් ඉච්චරයි. So example 192.1.6 is given. We should start from you l- low is 32 only, so we should add for the low, another low is, yeah, low is 32. So you take the what? Last usable ID of, like, last usable ID in management, like in management's last usable ID is 190, and at the size of low, which is 32, then you get the what? Last usable ID of low as 222. Was it very clear? Track up hand ගන්න එපා. Track up hand ගන්න එපා. හරි. How is it done? How is what done? So then from class B. Class B කරන්න ඕනේ. I won't think class. I'm not preparing the paper, but I do it. So if example, like yeah, I'm not clear with the question. Is 3041? Is your father Elon Musk? Just asking. 192.168.10. No, it's like for example, like if they have given that like here, like මෙතන දීලා තියෙනවා like if they have given it here, like if they what if they have given that value like in a diagram, yes, you should consider it. But අර නිකන් මෙතන වගේ දීලා තිබ්බනම් like 35, you start from zero. That's not an issue. But like if they have what like fill in the blanks වගේ දීලා තිබ්බොත් like I think it might be available as what fill in the blanks. I think what I think it's available. Yes, yeah. In that occasion, definitely you should follow that order. Good question. Good question. Like for example, like if yeah, if they say this is starting from, let's assume that they're telling this is starting from 64. Like if they're telling this is starting from 64, then you should what? Okay, this becomes 64. The first usable library becomes 65. Was it very clear? Then what are the size of it? Like make a size again. 64 and yeah, which means obviously the broadcast will be 127, and this becomes 126. Was it directly like if they have give like if they have given it as a fill in the blank, I think this year they might ask it as a fill in the blank, and I think yes. So Lama, if they have given the subnet mask like as a fill in the blank, please do according to that fill in the blank, okay? Okay, if it's 65, yeah, you make the next one as 65 like what, but it won't start from 65, it should start from 64. You can't start from 65, it's 64. If they have given service. Yes, you should consider. Yes, you should consider it as yes, you should consider. Definitely, yes, Sash. You should consider host. Yes. Host එකක් කියන්නේ මොකද්ද? Host එකක් කියන්නේ it's any what? Any device which is connected to a network. So like it could be what? So once again, host කියන්නේ any device which is connected to a network. That could be a printer. That could be what? That could be a computer. That could be a server. Whatever it is. When we divide, no, you should divide. Like you should take from zero. That's that's max. Okay, that's max. All right. So now you network ID starts on 64. How do you say it's 127? Because the size were make a size එක කීයද medical එකේ 64 is the size and you started from where 64 නේ. And since you take 64, obviously it should end from 127, right? Was it very clear? Yes. Mm. You guys are testing my patience a lot, okay. Awesome. Another time. Are we done? Yes. Okay. So if there is class, yeah. No, it's fine. So yeah, if there is a class, like if there is class B, you should you ask like how to do it, right? If it's class B, lamai like there yeah class B can what is the default subnet mask of class B? Default subnet mask of class B is what? Subnet class B hanne lamai class B they won't ask it. If they ask that won't happen lamai not at all. Like it's really difficult to do a class B one like divide yeah. So once again like class default subnet mask of class B is what 255.255.0.0 like in like if you take this kind of sub like and no point of doing this okay like this is the subnet mask in mind and once again subnet mask zero indicates what size of a subnet so, and once again how many zeros are available I mean there are freaking 16 zeros so which means how much is the size of what this kind of network 2 to the power 16 lamma 2 to the power 16 can give 65,536 it's 65,536 to the power 16. Yes, which means like this subnet has 65,520 536 addresses, man. Like literally ever asked to divide such and subnet. පිස්සුද ළමයි එහෙම හන්නේ නැහැ. It's not practical. පිස්සු. ඒක මේ මාදාන්න මේ පිස්සු ඇද. එහෙම දෙන්නේ නැහැ. ඕන්නම් මේව කරා like they might do something like this like until today I think they have not yet done like they'll use something like this like 192.125.2 dot like 0 slash what slash 23 okay this is possible slash 23 okay this is possible for sure this is possible slash 23 okay this is possible make a possible So what is meant by this? According to this scenario, there are 23 ones in the subnet mask, which means how many zeros are available? 9 zeros. So which means 2 to the power 9 can in such an scenario, okay, like the size of the subnet is 500. Okay, now this is possible for sure. Yeah, this is possible. This is possible. So once again, if they give us subnet mask something like this, now what? The size of the subnet will be 512. Okay, which means you need to now divide what 512 among whatever the number of departments they are asking to. Yeah. Then yeah, you can once again අර cake scene එක දාගන්න. 512 then subnet 4කට නම් බෙදාන වෙලාව 512 දෙකට බෙදාන්න it's what? It will be 200. One portion will be 256. Okay, if you divide it up into 4 lamai, one portion will be 128. One portion will be 128. Something like this. Yeah. Something like this. Yeah. Yeah, it's class. Yeah, it's class. Yes. It's classless. Yeah. So was it very clear? So that's this thing is possible, not class B, but this thing is possible. Slash 23 is possible. So if it's 23 lemma, there are 512 addresses, and if they ask you to divide it among 4 departments, just divide it equally among 4 departments, and one department will get 128 addresses. Uh, let's move next one. Okay, another what? Another important segment. What else should I do, Lama? Another important part. Yes, yes. Networking done. Yeah. Now my logic gates, no use of doing it. Okay, let's do what? Mm-hmm. Lama, shall we do the VR thing? Yeah. Shall we do the VR thing? Is it easy? ER and SQL on. Shall we do the Lama? Yeah. ER and SQL on. Yeah. Yes, yes. Let's do database. Okay, let's finish the database thing. Let's do yeah. These are good tape. Okay. So what I will consider the following what? Okay. Mm-hmm. I'll just what? I'll just these thing you can do it right. Lama, ER you can do it neither. Let's move to what? Part B. ER is easy. Below is what? Below is a personal insurance table showing the types of insurance that each person has obtained. It is what assume that a automobile insurance is not based on the what value of value of the vehicle, but it is on what insurance package scheme. Okay, there is what there is definite value for each type of insurance. The value of gold, silver, bronze packages of 5 million, 3.5 million, 2.5 million. Note the primary key of this table is what Lamini? Personal ID and insurance ID. Nice, nice, nice. Alright. So let's do this now. So once again, yeah. So like in this kind of question, Lamai. So first of all, is the problem. Yeah. It's what? It's personal. Yeah. The table is the name of the table is personal insurance table. Okay, and what happens there shows the what types of insurance each person has obtained. Okay, like types of insurance. Okay, each person has obtained. Nice, nice. It is assumed that okay, automobile insurance. Okay, the name of the insurance company is not based on value of the vehicle. Yeah. So once again, like they are not giving insurance policies based on the value of the vehicle, but based on insurance package scheme, like which means like they don't give you like insurance based on the value of the vehicle. Like there are packages gold, bronze, and silver. Like you should what take one of them, okay. Last one is only gonna. And what is the primary key of this table, It's personal ID and insurance ID. Okay, which means there is a composite primary key, Yeah, kids. Yeah, which means there is a what key composite primary key. So what is meant by a composite primary key? Composite primary key क्या a scenario where two or more columns are used to what create a primary key. So what is a composite primary key? A scenario where two or more keys are used to what create a primary key. Okay, nice. Write an SQL statement to display the number of uh, number of people who have purchased gold type what insurance, Lamai. So once again, yeah, like how to find the number of people who have obtained gold insurance type, Lamai. What is the answer? No idea. A similar one was available in 2020, Lama. Yes, what is the answer? You can write select. Select what? Lama, dagan select count. Select count. Select count. Select count. You can use select count. Okay, select count. You can use personal ID. Person ID. Select count person ID. From where am I? From where? So from person insurance table. Okay, person insurance table. Where what kids? Where insurance type equals gold. This is how you create an SQL statement. Patta simple ni select count personal ID, which means like here they are asking to display the number of person IDs, like the number of person IDs from what? From person insurance table, where insurance type is what gold. So like, okay, first of all, move to first person ID. So what about the insurance type? Is it gold? Okay, like then what? Then take the count of it. Okay, one. Then P2. Okay, P2, what is the insurance type? Bronze. So you don't take it. P3, okay, it's gold. You take it. So which means, yeah, now it count becomes 2. And yeah, P02, no, you don't take it because it's silver. P01, you don't take it because it's what? Silver. So once again, what is the answer? The count will be 2. Was it very clear, Lama? So what happens is like select count personal ID. Like here I'm asking what? Count the personal IDs from personal, like person insurance table where insurance type is equal to gold. So without that personal ID, will it be wrong? Yes, it's wrong. Like if you're like you should put something to count me. So you can what? You can either put here as what? Even you can use like as asterisk mark, Lama. You can use this asterisk mark. Select count asterisk mark. Yeah, but it should be available what? Inside bracket. This bracket is compulsory. This bracket is compulsory. You can use what? Asterisk mark, or else like this one is what way more like practical. So what am I doing? I'm asking what? I'm asking to count the number of personal IDs available in this table. We have what insurance type is gold. So hope it's very clear. Hope it's very clear. So that like you should insert something to count, and that should be inserted inside a what? Like a bracket. Next one. In which in which normalization does this table exist? That's a nice question. What is an answer? What is the answer? In which normal form is this what table is available? Can someone let me know very quickly? Nice, nice, good. So yeah, we have lots of answers. Good, huh? Well, like you guys know normalization, right? Second NF, right? Nice, nice, nice. Archie read the second NF. Anna parenda denne second NF. Second, second NF. Second, kiyanne second. Second, second, second නෙමෙයි first men. ඔක්කොම මන් දන්න ළමයි ඔක්කොම ටික. ඔක්කොම රොත්ත පිටින් කියන second NF කියලා. ළමයි, here we have what? Partial dependencies. Yes, here we have what? Partial dependency skills. Yeah, please. Don't, yeah, provide me heart attack. Yeah? Set exam, they're going to this kind of thing is questionable in your A-levels in tomorrow paper. This table is questionable. So once again, hagannuko. So now when it comes to, okay, I'll just teach you all part quickly. When it comes to normalization, Lama, in your syllabus, you'll be only learning what? Mainly, you'll be focusing on zero NF, which is what is known as unnormalized form, which is known as what? Bloody what? Unnormalized form. Next one will be what? One in if, one if, you know what's one in if, normal form, then you have what? Two in if, which is what? Simple form. Then you have what 3NA, which is what normal form, and you have what something called boys code normalization form, which is kind of product touch but not in paper. Yeah. Next one is boys code normalized form. BCDN. Yeah. So once again, Lamai, so once again, yeah, how to identify whether a table is in like how to identify whether a table is in unnormalized form. Lamai, ආවට ගියාට ගොන් ආතල් answers දෙන්න එපා. Like how to identify whether a table is available in zero normal form. Lamai, you can like yeah, you can identify a table in zero normal form if the what? If the primary key is not defined. What the hell is meant by that? Like which means in that table there is no primary key, is not defined. So Lamai, in this table they have given the primary key, right? Which is person ID and insurance ID. And if it has what? Multi-value attributes. If it has what? Multi-value attributes. Yeah, contains what? Like contains multi-value attributes. Like do we have multi-value attributes here? Just like see now like එක column එකක් ඇතුලේ what? Or එක cell එකක් ඇතුලේ do we have multi-values? Like do we have what? Two or more values inside one column? Do we have two or more values? No. I see no what? මන් දන්න ඔයාලට පේනවද? මට නම් පේන්නේ නැහැ. Contains what? Multi-values and composite attributes. Contain multi-values and what kids? Composite what? Composite attributes. Contain multi-values and composite attributes. Okay, simple. So then, yeah, like composite means like common attributes. Like for example, like if name is what? If name is divided as first name and L name, you should what? Write the column as if. So once again, my composite attributes can be something like this. Okay, I'll explain it very quickly. So like name, name is what? Name is divided as L name and L name and what lamai? Name is divided as L name and okay, name is divided as L name and F name. Okay. So once again, so according to this scenario, like what is the composite attribute? Name is the composite attribute. Composite attribute can the attributes which cannot be it can be divided further. So like when we are creating table lamai, you cannot what create a column called name. No, you cannot create a column called name. So if you create like that, the table will be available in zero normal form. You should create separate columns called L name and F name lemma. You should create other lemma. Yeah. So once again, according to this scenario, name is a composite attribute. What is the composite attribute? The attributes which can be divided further. So like if a table is to be like or else if a table contains composite attributes, that table will be available in zero normal form. So like simply the like table should not have composite attributes. Okay, hope it's very clear. Even yeah, even multi-value attributes, yes, yes, it's like that. You can't have it. That's what I mentioned here. And Lamai feels not atomic. Feels not at atomic means like what has happened is like feels not atomic means simply I'll just what tell you simply feels not atomic කියන්නේ atomic in a word is meaning a singular. Atomic means singular like fields are not singular. What is meant by that? For example, am I like if what if insurance value is once again repeated is if what insurance value column is once again repeated, that is what that is an example of fields are not being atomic. So fields should be what atomic lama atomic like which means like fields should be or else columns should be unique lama. Primary key not defined means like in that table you don't have a primary key yet. You don't have primary key. Then lamai contains what? Contains repeating groups. Contain repeating groups කියන්නේ like same row being repeated lamai. Same row being repeated. Yeah, that is what? That is containing repeating groups. Hope it's very clear. For example, like if this what? If this entry, like if the last entry is once again repeated, that is known as what? Repeating groups. Like what is repeating groups? Rows being repeated. Rows being repeated. Fields not atomic and columns being repeated. So if one of the following characteristics are available, ඔක්කොම ඕනේ නැහැ. ඔක්කොම ඕනේ නැහැ පිස්සුද? If all not required, even if one of the following characteristics are available, ළමයි, the table is in not zero normal form. So according to this scenario, like you have defined a primary key. So okay, ප්‍රශ්නයක් නැහැ. And it does not contain multi-value or composite attributes. And fields බලන්න ළමයි like have the columns be repeated, no personal ID, insurance ID. No. Okay. And Lama do we have like same like have an entire row being repeated Lama, right? Entire row has not been repeated, which means obviously this table is not in what? not in unnormalized form or zero normal form, which means this table should, yeah, should be in first normal form. At the moment, like we don't know whether it's in second or third, but we can tell, yeah, the table is not first normal form. Why is it? Yeah, now tell me the reason. Because in this table, my primary key is defined. Defined means like you have defined a primary key, like you have selected a primary key. Okay, like and I know what? No composite slash what kids? Multi-value. So no composite or multi-value what? Multi-value freaking attributes. Okay, next one is Lamai. Fields what? Fields atomic. Fields atomic. Can fields are freaking what? Freaking singular. Next one is what kids? Uh no what? No repeating groups. These are what? Real answers. No repeating groups. Okay, yeah. Then next one Lamai. So once again, like how can a table be in second normal form, Lamai? A table will be in second normal form only first of all, the first point is that it should be in first normal form. So if I ask you, Lamai, how can a student, yeah, Lamai, can someone let me know how can a student be in grade 2, Lamai? Just can someone, yeah, I mean, how can a student be in grade 2? I mean, how can a student be in grade 2? Obviously, the student should be in grade 1, right? Yeah, so that's very simple. Grade 1, ಇವಕ್ಕೆ ತಮ್ಮ like how can a table be in second normal form? The table should be in first normal form. ನಿಗ ಮೊಂಡಿ ಸೋರಿ ಲಮ ಇಟ್ಕಿಲ್ಲ ದಿನ ಹಾಗೆ ನೇದ. Yes, lama. Okay. And what is the other requirement plus no partial dependencies, kids? Yes, no what? No partial dependencies. Once again, kiddos, like first of all, how can a student be in grade 2? Okay, the student should be in grade 1 and yeah, should have passed what final examination. So likewise, naman, the table should be in first normal form and yeah, there should be no partial dependencies. And what is the next question? What the hell is what? What the hell is partial dependencies? Am I correct, Lamaini? Now that's your next question, right? Amata make a key like partial dependencies. Patlagan nipa Lamai. Yeah. Own nane the definition. Now, do you guys need a definition of partial dependencies? No, right? Own nane. Oh, Nane, you guys, yeah, who need a what? Definition for partial dependencies? Like, should I teach it? So yeah, once again, my partial dependencies kiyanni. Partial dependencies means. So once again, like, okay, when it comes to this table, first of all, identify what are the key attributes and what are the non-key attributes. Ka derunga. First of all, kids, yeah, when it comes to this table, what are the key attributes? Key attributes means the primary attributes. Like the attributes which is what helping to create the primary key. These are primary attributes, like or as key attributes. These are non-key attributes. These two are what? Non-key. I'll just what write as non-key. Yeah, it's key attributes. Like it was it very clear? Yes, right. Interesting. So once again, kids, what is second normal form? Like sorry, what is partial dependencies? Partial dependencies can be if non-key attributes are fully functional depending on part of the composite primary key. That is what? That is what, kids? Non-key attributes. Yes, that is what, kids. Not sorry. That is partial dependency. That is what, kids. Partial dependency. Once again, what is partial dependencies? If non-key attributes. So in this table, what are the non-key attributes? Insurance type and insurance value. If one of them are fully functional depending on one of the or is part of a composite primary key, which means like either on insurance ID or either person ID. That is what? That is partial dependencies. That is what, kids? Partial dependencies. So in this scenario, yeah, insurance type, which is a non-key attribute, is fully functional depending on insurance ID, which is what? Which is a part of composite primary key. Like if it's one, if insurance ID is one, it's gold. It's always gold here. Yes. Which one? It's gold. And if insurance ID is two, it's what? It's silver. It's silver. And if it's three, it's bronze, which means like bronze, which means obviously, kids. Which means what? Yeah, which means what, Lamine? Which means obviously, second, which means obviously, insurance type, which is a non-key attribute, insurance type, which is a non-key attribute, is fully functional depending on insurance ID, which is a what? Which is a part of composite primary key. That is known as what, Lamine? Partial dependency. So is it very clear? Was it very clear? Yes or no, Lamai? So once again, that is partial dependency. What is partial dependency? So before moving to partial dependency, you guys should know what is what. What is key attributes and what is non-key attributes. Key attributes can the attributes which are what used to create the primary key. Non-key attributes can the remaining attributes of a table. So like in a table, if non-key attributes according to this scenario, like insurance type or insurance value, if the non-key attributes are fully functional depending on not the composite primary key, like you need not to have the composite primary key to like uniquely identify it. Even if you have part of a composite primary key, like if you can uniquely identify that make column, that is partial dependencies, and that is what is available here. Like insurance type, which is non-key attribute, is fully functional depending on insurance ID. It's like itself, Lamai, or it's like simply like if you know insurance ID only, Lamai, you can determine insurance type. So like you need not to have this personal ID. So that is what that is partial dependency. So it's very clear. Yes or no? Make it quick. Nice. 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 So hope it's very clear. මෙතන මට ලස්සන මැසේජ් එකක් ඇවිල්ලා මට කියන්න බෑ. කියන්න බෑ. හරි. So that means there should definitely be a composite primary key to have a partial dependence, right? Yes, Olini. Your answer is perfect. So Olini is telling so, which means like in a table, like to yeah, to have an composite, sorry, to have partial dependencies, definitely there should be composite primary key. Definitely, yes, in a table, definitely you should have composite primary. There should be a composite primary key to what? To have partial dependencies. Yes. So yeah, if you give without count, it's wrong. Insurance, what about insurance value? Like, the insurance value, it's not dependent. Is it depending on what? Insurance ID, like here, when insurance ID is on, here the insurance value is what? Here, but yeah, well, that is depending. Yeah, it's depending now. Yeah, it's depending. Even lama insurance. Even insurance value is depending on insurance ID, right? Am I correct? Yes, it's depending. Yeah, even that is partial dependencies. So, for example, like if it's one llama, it's 50,000. If it's three, it's 25. Sorry, 5 million. If it's three, it's 2.5 million. Sorry, if it's one, if it's 5 million. If it's three llama, it's 2.5 million. If it's one second five, it's 5 million. Yeah, even that is partial dependencies. Llama. Yeah. So, which means you should remove this sheet as well as one, as well as this sheet. Dekama inkarana. So can primary key be repeated? No, who said primary key can be repeated? Here it's not repeated. Here the primary key is what personal ID and what insurance ID, the both. So it's like not repeated. So a table cannot contain a derived attribute, right? A table can, if a table is in second normal form, it cannot contain derived attribute. Third normal form. So according to this scenario, there are what, two partial dependence, and you should what, remove all these two. Yeah. According to the answer will be what, Lamai? The answer will be the table will be in first normal form. So like the table will be what line? First NF. Why first NF? If someone ask me like why first NF? So first of all, you can write because what primary key is defined, no composite attributes, fields are atomic and no repeating groups plus. Then write why it is not in second normal form. Why is it? Because it has partial dependencies, and why is it not in third normal form? Like, third only like yeah, it's not in second normal form because what there are partial dependencies. Yes, it's composite. Yes. So was it very clear, Lama? Please justify your answer, okay? So what is the answer? The above mentioned table is in first normal form. What is the first reason? Okay, primary key is defined, no composite attributes, no multi attributes, fields atomic, no repeating groups. And why is it not in second normal form? Because what there are partial dependencies. Convert the above what table to next normal form. Mihimai. So yeah, need not to write that contain available in the data. So let's move to relational scheme. Okay, like there's something called personal insurance. Okay, there's yeah, personal insurance and what are the like අතල මොනවද තිබ්බේ ළමයි යා we had what personal ID please ළමයි යා මම මේ ඔක්කොම කැපිටල් ලිව්වට ඔයාලා මෙහෙම ලියන්න එපා you guys don't write it like this okay just write it as it is like simple, capital, non-capital. So please what? Please write it like that. Okay, insurance ID. Then you have insurance type, and what else am I in? Yeah, you have finally you have what? Insurance value, right? Finally you have insurance. Yes. So yeah, according to this scenario, what is the primary key am I? This two ne. Now this is in first normal form ne. So yeah, just translate to second ne. Mela it goes to third now. Second in first is killing second me third degree now. Why is it? Because when you remove partial dependencies, CLMI, like there are no transitive dependencies. Personal insurance. And simply, yeah, you can in this table, you can what? You can click personal ID and only what? And only insurance ID. Yeah, yeah. You can simply what? You can simply remove insurance type as well as insurance value. So this is available in first normal form. මේ ලබ්බ තිබ්බේ කොයිද නම මේක තියෙන්නේ first normal form එකේ. Now this shit is available in what? Straight away third normal form, not second normal form, straight away third normal form. Why is it like when you remove the what? Partial dependencies from this table, like there were no transitive dependencies, which automatically makes it in third normal form. And ළමයි, yeah. So remove කරපුවා පල්ලට දාන්න බෑ. What happens ළමයි? So like you should separately create a table called insurance. Like you can use whatever the name is. That's not an issue. The practical name, yeah, insurance කියන ගැලපෙනවනේ. And create a table called insurance and put their what? Insurance ID along with what? Along with the attributes which you like removed. What did you remove? Insurance type and insurance. Well, yeah. And once again, this table is also what? In third normal form. Create करबो काम बड़ो in the third normal. Why is it? Because like the primary key is defined. Once again, yeah, the fields are atomic, no repeating groups, blah blah blah, no partial dependence as well as no trans. But yeah, partial. Yes, yeah, make me I know. Yeah, once again in a second normal form. This table is in second normal form because now metana partial dependency එකක් තියෙනවා. So like when you what? ඉච්චර දුර ඕනේ නෑ. Like these are too much. So once again, like if you contain this take this insurance table lamai, you can clearly see what insurance value is depending on insurance type, right? So both are non-key attributes. So like which means this table is in a second normal form. If you want to go on, if you want to what move this table to third normal form, remove insurance value as well. Yes. You seen that. Was that very anyway, Lamaya? Was it very clear? Can someone let me know? So once again, what happened here, Lamai? So here what happened was like here we have the table personal insurance and what is the composite primary key, personal ID and insurance ID. And according to this, like insurance type and insurance value, both are depending on insurance ID. So like that is partial dependencies. So you should remove it. Okay. So you create the table personal insurance. Okay, like inside that only personal ID and insurance ID is available. And what about the removed attributes, Ramai? That will be what going inside a new table called insurance along with the insurance ID. So and this table is in second normal form because Rama, here we have transitive dependencies. What is transitive dependencies? In a table, if non-key attributes are fully functional depending on another non-key attribute. So here in this scenario, you can see Lama, like insurance value, which is a non-key attribute, is depending on insurance type Lama. Like if it's what? If it's 5 million, it's like sorry, if it's gold, it's 5 million. It's always 5 million. If it's gold, it's always 5 million. And if it's silver, it's always what 3.5 million. So which means like methana transitive dependence. Separately, you have transitive dependence. So that makes the second table or else this insurance table in second normal. If you want, you can what? Remove that dependencies as well. So how to remove it? Yeah, just what? Remove insurance value now. Just remove insurance value and insert it among another table. ඒක අහලා නැහැ. They have not asked that. Okay, like මම මේ දුර මම කරන්නේ. I'm just what? Doing it for the curiosity, okay, of the students. Yeah. So you can what? You can take this table out and once you can turn it to what? Third normal form. How turn it lamai? Insurance gatta and put what? put here insurance ID. Yeah, you can what? You can put insurance ID along with what? Along with insurance type. And what happens? Get a separate table called what? Create a separate table called invalue කියලා දාන්න. Invalue කියලා දාන්න. And okay, yeah. Okay, දාගන්න මොනවද? Insurance type along with that. Insurance type. So what happened here was lama, yeah. What happened here lama? Here what happened was like, okay, this table which is in second normal form, I just convert to third normal. By removing what? By removing, to be precise, I increment I removed here transitive dependencies. What were the transitive dependencies? Insurance value was depending on insurance type. Ne? So I just removed insurance value from this table and insert in another new table. And the name of the table is in value. So you put insurance value along with the insurance type. Ah, so was it very clear? කියන්න ළමයි මේක තේරුණාද? Transitive dependencies, partial dependencies, was it clear? Partial dependencies කියන්නේ non-key attributes are fully function depending on part of a composite primary. Transitive කියන්නේ non-key attribute is what? Fully functional depending on another non-key attributes. Like for example, when you take insurance table, like you have insurance ID, insurance type and insurance value. So here insurance type and insurance value are non-key attributes. And in this scenario, insurance value is depending on insurance type. So what I did was Lamai, I just removed insurance value from this insurance table, which made it work to third normal form. And separately, I just create a table for insurance value along with insurance type. And that table is also in third normal form. So why did you take this type? Why do you take yeah okay make it I insurance okay why you're asking why do you took it as primary key then? Because here like in this scenario you can clearly see insurance type අනිත් පැත්තට යලා තියෙනවා. Yeah. And yeah. Once again, in this what in this scenario you can clearly see lama insurance value is only depending on insurance type ne lama which means the main guy is what insurance type ne. So that's why I took it as the primary key. Like here value is depending on insurance type no. So that is the main guy. So that's why I make it primary keys. Lama, is it very clear? That is what transit dependence is. Yes, right? Good. Lama, janna ආයෙ normalization කරන්න කියන්න එපා. It's fully cleared. අර නේ ළමයි. I just what went to the extreme, okay? No need to go to this extreme. Okay. කොහොමත් HTML it'll be CSS will be tested. We don't have time, otherwise I'll do. Python කරේ නැත්තම් නිකන් මොනවාද ළමයිනේ. Shall we do a Python now? Don't we have a Python question? We don't have Python. Alright. Okay, so once again, should I do this memory management thing? Lama, should I do this memory management? Should start this will become what? I love a question. Okay, then I once again Lama, don't try to school me. Mom मेरे साथ jet bullet वगैरह कराने ना, but तेरे उन्नत मत वाइन देवा. Don't school me, okay? Can't help. Try to once again, please what? Please try to bear with me and yeah, mom me like magi cutting की हमें काम तेरुंगा. Try to what? Understand each word which is coming out of my mouth. Lama, please what? Please focus now. Please focus. Once again, I cannot repeat these things because we don't have time. So like, please focus. Please focus on the words which is coming out of my mouth. Yeah. So one thing, yeah. Focus, okay? මුලේ මෙතනට ගන්න දැන්. මුලේ වෙන තැන් වලට යන්න එපා. Yeah, just what? Focus here. The length of what? The length of virtual memory address. Okay, like the length of virtual address is on a byte addressable complete is what? 16 bits. Okay, which means lama, yeah. When it comes to what? When it comes to virtual memory, yeah. When it comes to virtual memory, lama, what is virtual memory? Virtual memory කියන්නේ it is what? It is a part of a. It is a part of a hard disk which is temporarily converted to main memory in order to execute programs which are larger than the size of uh, main memory. Once again, what is virtual memory? It is a part of a hard disk which is temporary. It is a part of hard disk, a part of hard disk which is temporarily converted to main memory to execute programs which are larger than the size of main memory. So, like when it comes to virtual memory, how to calculate the size of it, Lamai? There are two methods. First of all, we can take the what? Number of freaking addresses, like number of virtual addresses. So, now, I mean, virtual addresses are also known as logical addresses. Okay, number of virtual addresses, logical addresses, multiply by size of virtual address. Size of virtual address. Okay, just what? Just multiply it by what? Size of size of what? Size of virtual address. Okay, nice, nice, nice. And what is the second method? Like? The second method will be number of pages. Okay, Lama, you guys know what's a page, right? So number of pages. Page again, it's a fixed size memory block of ROM, Lama. That's a fixed size memory block of virtual memory. So like these could be like ROM move activities. Like seven might use different kinds of names like பயனிவா பயப்படாதே நாங்கள் எல்லாரும் இலங்கை பிரச்சனையாகவும் இலங்கை கிச்சனையாகவும் yeah number of pages multiplied by page size. Don't mix these what please in the formula देखा mix करके नहीं पा please don't mix it. Okay, so once again what is virtual memory, how to calculate virtual memory दान how to calculate the size of virtual memory हमारे number of virtual addresses or logical address multiplied by size of virtual address to logical address, or as number of pages multiplied by sorry page size. It should be number of pages multiplied by page size. So according to this scenario, Lamai, they have given the number of like yeah, they have given the number of virtual address. Meaning the length of the virtual address, virtual memory address on a byte addressable computer is 16 bits, which means Lamai, the number of virtual addresses are 2 to the power 16. When okay, again number of what? So like they have given the length of virtual address as 16 bits, which means the number of virtual address are to the power 16, and multiply the size of virtual address. Like a byte addressable computer means by default, the capacity or the size of one virtual address is 1 byte. So byte addressable memory can the size of one address is 1 byte. So once again, am I, yeah, the length of a virtual memory is how much? The length of virtual memory address is 16 bits, which means the number of virtual addresses are to the power 16. And how much is the like size Lamine? It's a byte addressable computer. And by default, the size will be 1 byte. So which means how much is size of virtual memory? 2 to the power 16 bytes, right? Am I correct, Lamine? So 2 to the power 16 bytes, can someone let me in KB, Lamine? Just divide it by 2 to the power 10, you get the answer in KB. The answer in KB is 2 to the power 6, right? 2 to the power 6 KB is it 64 KB? Can someone let me know? Yeah, it's 64 KB, right? Interesting, interesting, interesting. So let's move to the next one. Consider the physical memory. They have given what? They have given the size of physical memory as well. Nice, nice, interesting. We are getting somewhere. The size of physical memory, like the physical memory can another the RAM. So once again, when doing such a question, identify all these shit. Okay. So once again, the size of what? The size of RAM or the physical memory is how much? 32 KB, but the size of virtual memory or the ROM is 64 KB. And Lamai, how much is the page size? And yeah, before yeah, I'll tell this as well. Lamai, when it comes to RAM or the physical memory, like you can call it what? The physical memory, bloody what? You can call it physical memory, or else you can call it whatever. Right. So how to calculate the size of RAM line or physical memory? Once again, two methods. Number of what? Number of physical addresses multiply by size of what? Size of physical address. Nice. And yeah, and once again, what happens, Lamine? What happens is the second method is what? Second method is number of frames. Okay, what the hell is frames, Lamine? Frames can fix size memory block of RAM. RAM make fixed size memory block किया था fixed size memory block of sorry physical memory. Anyway you can call, yeah, then frame multiply by yeah frame size. And the most important point is Lamaini. The most important point is page size equals frame size. I kill hanne pa I never gun and get meter malapai. Don't ask why, because no time to what. I have explained it why to the students who came to my class. Like memang danut bang duganan kya mati, but no time apara duganan. The opportunity cost is very high. The time is more important than. Right. Frame size equals what? How the exam के मानना ही था नहीं like why frame size is equal to what? page size කියලා මම හිතන්නේ හයි කියලා like anyway ඇහුවත් ළමයි the reason like why it's equal is like the same process is only being stored in different locations, so the size is equal, like same process is only stored in different locations, so size is equal, or it's like simply you can say page size is equal to frame size. This is, yeah, and this is equal to how much? The page size is how much? Size of page is 2 KB. All right. 2 KB, right? Yeah, and yeah, which means page size is also 2 KB. Frame size is also freaking 2 KB. Okay, nice and interesting. Okay, what happens now? Yeah, the virtual address is 16 bits. Yes, Lamai, which consists of page number in bits and offset in bits. Wow, wow, wow. Respectively, how many bits does the what computer need to have to represent the offset? Wow, I just told I just told these things like nothing, man. Can you remember Lamai, like the conversation at up? That one page, can you guys remember the one page? Yeah, the one page. The reason for the success is what Lamai? One page. Even message out. Me, Lamai, one page, like in this one page, all the things are available. Now, me think, yeah, yeah, virtual address and physical address. I think that yeah. What I was amazed was Lamai, me balana like, like ලස්සන්ට කියනවා. විතර බලන්න විතර ලස්සන්ට කියනවා like මගේ නෝට් එකෙත් එහෙම දාද මෙතන. So එළවලිය. Virtual address is 16 bits, consist of page numbered bits. Okay, page number in bits and offset in bits. Okay, මේ තියෙන්නේ. ඔක තමයි මාත් කියන්නේ. Virtual address එකේ දෙන්නේ page no in bits and page size or else offset in bits. Yeah. දැක්කද? I was like amazed by that ළමයි. මත් උහුම්ම තමයි. In frame එකක් දිය frame number in bits and අමෙදි frame number in bits and physical address එකේ දෙන්නේ frame number in bits and frame size in bits or else offset in bits. Yeah. So once again ළමයි. So once again, so up to this point, was it very clear? LMI, like there are two addresses. What are the two addresses? Virtual address and like the logical address of the virtual address. Same thing, okay? Logical virtual, don't what? Don't get confused. My examiner might try to what? Confuse it. Yeah. Same thing, yeah. Address. And Lama, this side you have the what? Physical address. So when it comes to these addresses, Lama, like they are formed with two portions, okay? They are formed with two portions. So as I mentioned earlier, like virtual address kin lamai කොහෙද ළමයි? It's available where? In a virtual memory. So here, yeah, in virtual memory only we have pages, right? So here you have what? Page number. Yeah, it's formed by page number in bits, and you can say offset in bits. So like you can say page size in bits. So once again, kids, Lamaini, how does the virtual what? Virtual or logical address is being formed, page number in bits. Take a page size in bits, okay? Or else you can say offset in bits. Offset bits. Here my physical address එක දෙන්නේ කොහොමද ළමයි? Frame number in bits multiply by frame size. Oh, sorry, frame size. So offset in bits. So hope it's very clear. Okay, like hope it's very clear. So once again, what is the like what? Okay, let's come here, ළමයි. And here they are saying, okay, the total size of like make it the entire what? The total length is 16. And they are asking, ළමයි, what are they asking? They're asking the page number in bits and page size in bits or as offset in bits. Lamai. So they have given the page size, right? Kids, Matakan kiddos, like they have given the page size near there. They have given the page size near. How much is page size, kids? How much is page size? Page size is how much, Lamai? It's 2 KB, right? So the first thing you should do is convert this 2 KB into what? Bytes, Lamai. Just වෙන්න දේවල් කරන්න එපා, just convert this into bytes. ළමයි 2KB like how how many bytes is it ළමයිනේ? Is it 2 to the power 11 ළමයි? That one a conversion, you know it, right? Yeah. 2 to the power 1 KB, yeah. And if you make it bytes, whatever, so it becomes to the power 11 bytes, right, Lamai? Yeah, the page size in bytes, it's 11 bytes, ne? Which means here, yeah, it's to the power 11, which makes, yeah, which makes the page size in bits how much, Lamai? 11. Interesting, right? Okay, interesting. So as I mentioned earlier, among calling as I mentioned earlier, a virtual address or a logical address is the combination of page number in bits and page size in bits. Like out of 16 bits, if 11 bits are what? Like representing offset to page size, how many bits will be representing the page number? Kian, how many bits will be representing the page number? Obviously 5 bits, right? Was it very clear? So the key point is now the page size is 4 KB, and I just asked you to calculate it to bytes. So 4 KB is equal to the power 11 bytes, which means like here it's 11, it's to the power 11 again, yeah. The page size in bits is 11, lama, like it's 11, and which means the page number in bits is 5 bits. Was it very clear, kiddos? Yes, right? Was it very clear? Yes. Oh no, Kiana Lama, was it very clear? Interesting. Yeah. Others, yeah, what happened to you guys? Yeah, it's clear, right? So once again, Lamai, they have given like once again, Lamai, virtual address is the combination of what? Page number in bits and page size in bits. Okay. So they have given the page size in, yeah, it's kilobytes, 2 kilobytes, and just convert it to bytes. It's to the power 11. Just take the like page size. Yeah. That's how you tell in bits, Lamai. Bytes will take and it's 2 to the power 11 bytes. And then 11 become the number of like uh, that will become the page size in bits. And virtual address is 16 bits name. So like from 16 bits, when you reduce 11 lamai, automatically you get the what, page number in bits, which is obviously 5. Superior. Like they have only asked up to this point, okay? Like they have only asked up to this point. They're not Chara. How many yeah, how many bits? Yeah. First of all, they're asking how many bits are required to represent the offset, right? Offset 11 bits. And how many how many bits of address I need to store a page number? To store a page number, how many bits are required? 5 freaking bits. Simple means simple. You got to get. Or, ඕන්න නේද? ඕන්නම් අපි යා ළමයි මේකෙත් එහෙමද ඕන්නන්නේ? Shall we what? Shall we separately find the frame number in bits and frame size in bits as well? So like obviously page size in bits like 11 now. Obviously what frame size in bits also it should be also what? It should be 11 bits. My page size is equal to frame size, which means what? Page size in bits will be also equal to frame size in bits. Like simple. The frame size got that even that is 2 KB. It's like even 2 KB when you convert it to bytes, it will be 2 to the power 1, which makes what? Frame size of the offset in bits 11 bits. And now you need to find the frame number in bits domain. And like that is a kind of challenging because they have not given the total length of physical address, right? Have they given the total length of physical address? No, right? No. Now, like another, like, shall I tell you all the method of calculating the frame number in bits directly? Shall I tell you all the formula now? The method of calculating frame number in bits. Shall I tell you all? But will it be confusing? Like you know frame size in bits, which is 11. But actually you don't know the frame number in bits. Because like we don't know what? We don't know the total like length of physical address as well. Yeah, yeah, good, good, good. Yeah, but the thing is, it's available in that's what. Hold on. So they have, yeah, once again, Lama, they have given the total size of physical memory. So once again, kids, they have given the total size of what? Total size of physical memory, which is 32 KB. Okay. And Lama, how much was the size of a frame? Size of a frame equals what? It's 2 KB, right? Which means how many frames are available? Number of frames, Lama. You can use the second formula. Yeah, size of physical memory equals number of frames multiplied by frame size. So you know the size, which is what? Which is 32 KB. And you know the size of a frame, which is what? Which is 2 KB, and which means how many frames are available? There are 16 frames, right? Am I correct, kids? So 16 can 2 to the power here. Then 16 means 2 to the power 4, right? Which means 4 bits are required to represent the pages. Easy, easy, easy. And which means like, how much is the like total bits of physical address? Like total how many bits are available? There are 15 bits. How come 15 bits? 11 for offset, 4 for what? Frame number, like that's what in frame number in bits. So once again, first of all, I calculate the number of pages. How to calculate the number of pages? Just revise this equation. When size of physical memory equals number of pages multiplied by, sorry, number of frames multiplied by frame size. So once again, size of physical memory size equals number of frames multiplied by frame size. According to scenario, you know the what size, which is 32. But you don't know the number of pages, but you know the what size of a frame as well, which is what? Which is 2K, which means obviously number of frames should be 16, right? So because 16 multiplied by 2KB only, the answer will be 32KB, which means number of frames are 16. So 16 till me in 2 to the power form, it's 2 to the power 4, right? Which means, yeah, how much is the frame number in bits? It's 4, right? Clear? Is it clear? And Lama, yeah. And the total bits of physical address is 15 as well. Like if you want, you can confirm this as well. Go confirm karne. Just move to the first method. Like first method of calculating size of physical memory. Number of physical addresses multiplied by size of what? Size of physical address. So here you know the what? You know the physical memory size. Anna size is 32 KB. And you know the size of what? A physical address, which is what? Which is 1 byte, because it's a byte addressable memory. And obviously, yeah, 32 KB can lama, it's 2 to the power 15 KB can again. 2 to the power 50, sorry, 2 to the power 15 bytes can again. So which means obviously how much should be the number of physical addresses? 2 to the power 15. 2 to the power 15 can, yeah. How many bits are available in address? 15 bits. It's confirmed that your answer is correct. I mean, like, make it you can confirm, yeah, whether your answer is correct. So once again, what was the size of the physical memory? 32 KB, 32 KB. First of all, yeah, write it in bytes. Bytes to the power 15 bytes is equal to number of physical address multiplied by size of physical address. How much is the size of physical address? It's 1 byte. I mean, 1 byte, like it's a byte addressable memory. And you do know the number of physical address. So what multiply by 1 byte will give you 2 to the power 15? It's obviously 2 to the power 15. So which means the number of physical address are 2 to the power 15, which means how much is the bits per physical address? 50. Are we going yet galloping? Was it clear? Yeah, na? Simple. Eh? Lama, isn't it simple? Isn't it simple? Just let me know, Lama. Isn't it simple? It's more than simple. Right? The key point is, Lama, like these two like calculations. Physical memory, you can calculate it using number of physical address multiplied by size of physical address, or as number of frames multiplied by frames. Right? Virtual memory, Lama, number of virtual address multiplied by size of virtual address, and another number of pages multiplied by pages. If someone asks me, "Sir, how many pages are available?" Like, yeah, about Lama, how many pages are available? So this virtual memory size is 64 KB. Number of pages here, and page size is 2. Obviously, number of pages here. Just divide 64 by 2. Is it 32? It's 32, right? Number of pages are 30. Number of pages 32. Number of frames 60. Sir, sir, size of physical address equals. Yeah, size of physical address equals. Yeah. This size capacity same nih. Size keyword capacity දෙක එකයි නේ. මෙතන size keyword capacity keyword දෙක භූත අසේ. Correct. So once again, number of, yeah, now we know plenty of things. Like number of pages, this the guy number of frames or number of frames. That's where again. Once again, how many bits were required to represent a page number? 5 bits. Why is it? Third two can two to the power, okay, the two to the power 5. Oh, Hingiat can appear, okay. What lazy. From where you calculate the, yeah, like if you calculate it correctly, mean Hingiat the finally, yeah, all the answers should be like equal. Like there are plenty of methods like to check whether you have taken the correct answer. Like we have just what? drank this question. I just what drank this question. Correct. So, was it very clear? Kids, I want a quick response. After this one, is it very clear? Yes or no? Yes or no? Yeah, virtual memory size was 64 KB, physical memory size was 32 KB. And once again, virtual address is 16 bits, which is consisting of what? 5 bits and offset of 11 bits, and physical address is 15. And yeah, it contain what? 4 bits of frame number in bits is 4 bits, and obviously offset will be also 11, which is equal to here. Yeah, person and page size, frame size become equal 2 KB, 2 KB. And how many frames are available? 16. And how many pages are available? 32. Simple. Simple. Like, yeah, button. Come, hear me? Just remember, yeah, just what? Remember those values when you are doing this thing as well. Because they are given the page table. So, Lamai, once again, what is the page table? Page table can it is a data structure. It is a data structure uh which maps page numbers to corresponding frame numbers. Godak Lamaya. If I ask you all what is a page table, you guys will tell it's a what? It's a table which maps virtual addresses to me physical addresses. No. ළමයිනේ page table එකක් කියන්නේ ළමයි page table is not something which maps individual what virtual addresses to individual physical addresses. No. What What does a page table do, Lamai? Page table is a data structure page numbers, which maps page numbers to corresponding frame numbers. Hope it's very clear. That is what is done by a what? Page table. Page table simply what? Maps page numbers, not virtual addresses, but page numbers to corresponding frame numbers, not physical addresses. Understand the real logic. Don't memorize this shit. Please. A kind request. Don't memorize. Don't memorize this shit. Terunada, was it clear? Hmm? Yeah. So once again, that is a page table. And in page table, what is meant by these ones and zeros? So once again, what is meant by these ones and zeros? Like there are ones and like one making indicate like what is indicated by one? One means at the moment, the like the zeroth page is available or mapped to fifth frame la frame can it's main memory or is the RAM name. So which is at the moment the zeroth page or a zeroth part of the process or zeroth what part of the virtual memory make it in ඔක්කොම දේවල් entire data is available or mapped to fifth frame lamai. So like if it's zero, no, it's not available in the main memory. The particular page is not available in the frame. If it's one, like it's one, so like so which means the content or the addresses, the addresses which is available in a frame 3 is at the moment mapped to sorry the content the data which is available in page number 3 at the moment is mapped to or it's available in the main memory and mona frame again it's available in the sixth frame. And what about the data or the number of addresses which are available in the fourth page is at the moment mapped to third frame which is in main memory. So that is what is meant by 1 and 0. 0 can the content at the moment is not simply the page is at the moment not available in the frame of the main memory. One can at the moment yes the particular page is available in the main memory and it's mapped to the corresponding frame. Frame map kar di. Kids, are we done? Like are we good? Like up to this point, yes, it's clear, right? Nice and yeah, nice and interesting, nice and interesting. So let's move to this scene. And what are they saying? Now my address on zeroth page. Look, like in zeroth page, how many addresses are available? Am I? So once again, zeroth page consists of what? 0 to 200 and what? 40 0 to what? 0 to 247 virtual addresses, right? Yeah, it comes from 0 to, there's a Yang game not thin, it contains from what? 2048 to 2048 to how much am I? 9,000 what? Sorry, 4,095. 4,000 what? 4,000 freaking 95. Was it very clear? Yes, right? So once again, Lamai, like, Lamai, how much is the page size, Lamai? Page size is how much? Can someone can remember how much is the page size? They gave a page size. How much is the size of a page, Lamai? How much is it? 2 KB, right? It's just 2 KB, right? Am I correct? So just tell me 2 KB can hear the 2 to the what? To the power 11 can 2 KB can to the power 11 bytes ne. So to the power 11 bytes can how much is it, Lamai? To the power 11 can how the? Here, 2000. 2048 addresses, which means inside one page or one frame you can insert how many addresses? 2048. ඔක ඇත්තටම මේක කියන්න ඕනෙත් නෑ ළමයි. They need not to say this ළමයි. යාලා ඇත්තටම හොඳයි, like they have told it. ඔබ කියන්න ඕනෙත් නෑ how much is the size of a page? It was 2 KB, right? 2 KB means once again remember it's to the power 11 ne. To the power 11, to the power 11 can 2048, which means inside one page how many addresses are available? 2048. Since it's starting from 0, it's ending from 2047. Then next one it's starting from 2014, it's ending from 4095. And once again, each page consists of 2048 addresses. Understand the logic, kids. Understand the freaking logic. Was it very clear? And if I may went like further am I, like if you ask me, say what is available in the second page, okay, what's available? It's from what? 4,000, yeah, what's available from 4,096 up to mang hitan ni yeah, 6,000. I think it's what, 6,144. Can someone confirm it to me? So sorry, 43. Sorry, 43. Yeah, it's 43. Yes, right. So if you ask me, sir, what is available in the next one? Okay, you start from 6,000 what? Oh, Mediterranean, okay, then it's easy one. Yeah, it starts from 6,144 and it ends from where am I? 8,000, 8,191. So once again, what gap पे की है? The 2,000 what? Like what is like inside each page? जब मैं बाइला कहा inside each page there are about 2,040 addresses. Because the page size is how much? 2 KB. 2 KB can 2 to the power 11, 2 to the power 11 can 2,040. अरे ओना इलायत बला kan इलायत तीन तो ना. इलायत तीन what? From 8,192 up to what? You can write 10,000. Yeah, it's it's 10,239, I guess. Yeah, 10,239. So it's yeah. Someone can you confirm it? Yeah, I think it's right. No, Harini. Yeah, Harini. All right. So you cannot. Pallet and you can go down. Villa කරන්න ඕනේ. So like ඕනම කරන්න බට. So next one. So once again, so once again, like, suppose this operation required the virtual address. Okay, now they need to obtain the virtual address. This one, lamai. So in a virtual address, lamai, 11 bits. What does 11 bits represents? 11 offset, which is like is offset, and what is the what? What is the part which represents the page number? What is the part which represents the page number? So this yeah, like page number is 5 bits. And once again, yeah, when it comes to a virtual address, remember 5 bits represents the what? Page number. 5 bits represents the page number. This one you offset ne. So how much is page number? 0. Yeah, something like this, right? Uh-huh. Uh, uh, Yeah, am I correct, kids? yes or no. මෙතන පොඩි අවුලක් තියෙනවා වගේ පේන්නේ. Yes. Yeah, මම පොඩ්ඩක් මේක වෙනස් කරන්නම් ලා. I'll just change it a bit because whether there is a printing mistake. There is a printing mistake. There is a printing mistake. Yeah, there is a printing mistake. So yeah, confused වෙන්න දෙයක් නෑ කොහමද? Yeah, just yeah, I'll just change this one. Change this to how much? Zero, zero, zero. Okay, zero, zero. Okay, so I just change it to what, Lamine? 0010. Okay, like once again, what did I do, Lamine? Yeah, this is what. Just consider this as the virtual address. Okay, so what is the virtual address? 0010, and the remaining thing is like that. So once again, remember, Lamine, page number is represented by the what? First 5 bits. Yeah, the first 5 bits represents the page number. So which means the page number is 00100, right? Lamai, like, what is the decimal value of it? Is it 4? So which means which page are they eh, referring, Lamai? They are referring fourth page, right? They are referring fourth page, Lamai. And at the moment, fourth page is what? Mapped to which frame, Lamai? Fourth page is mapped to which frame? Third frame, right? So like they're asking explain yeah, which physical address to which the above virtual address will be mapped to. So once again, write the offset as it is because like offset is not changing it. Offset is similar. So what is the offset? These 11 bits 000000010. My offset will not change. Just write the offset as it is. This is the offset. And my physical address के मुकाबले नहीं physical like physical address have you have the frame number in bits, right? And for frame number, how many bits are allocated? For frame number, we allocate 4 bits. So which means yeah, and the frame number in decimal is how much? 3. So yeah, just tell me 3 in 5 bits, lamai. 3 in 5 bits, how much is it? 0, 0. Sorry, you allocate only. So once again, sorry me. Yeah, frame number we allocate only 4 bits, right? Yeah, only 4 bits. Sorry, only 4 bits. Sorry, only 4 bits. Which means yeah, indicate yeah, frame number then key the 3 ne. Yeah, 3 indicate in 4 bits. 4 yeah, 3 indicate in 4-bit binary form It's 0, 0. How much is it? 0, 0, 1, 1. This is the answer. 0, 0, 1, 1. This will be the yes. So once again, what did I do? So they have again in simple terms, what did I do? They have given the virtual address. So in this virtual address, I just separated the what? I just separated the page number in bits and offset in bits, and just yeah, offset in bits. I just took it and I just what wrote it as it is because like offset is the same element. Virtual address or physical address, offset is the same. So like I just wrote this what? This is same lamai is equal. So what is changing is lamai what? Like you remove what? You remove page number in bits, which is what? Which is 0, 0, 1, 0, 0. So 0, 0, 1, 0, 0 again, what is the page number? Page number is what, Lamai? Page number is me phone. So fourth page is what? Is assigned to which frame number? Third frame. So like then tell me how much is 3 in 4-bit binary form? Why 4-bit binary form? Because frame no should be represented in 4 bits. So it's what? 0, 0, 1, 1. So this is the answer. So explain why this is happened. So you explain, Lamai. So once again, what happened? So like the page you can write something like this. Yeah. So once again, in virtual address, the first 5 bits represents the page number. The remaining 11 bits represents the offset. And frame, yeah. How much is the page number? 0, 0, 1, 0, 0, which is equal to what? 4. And page number 4 is available in what? Frame number 3. And once again, offset is equal to offset. So offset is written as like this, Lama. And yeah, then frame number is represented in 4 bits. Yeah, then yeah, you convert 3 to 4-bit binary form, and the answer is 0, 0, 1. Was it very clear? Was it clear? Yes, right. I think it's clear, right? So that is what that is memory management. That is memory management. So Lama, other Athenian. So Lama, yeah. watch the other recording as well. ඒකේ Python හොඳටම කරලා තියෙනවා. I have done the Python, so like memory management hari, networking hari. So like, do I need to do something else? No, right? It's enough, right? තව මොකක් හරි දෙයක් කරන්න ඕද? No, because like, well, won't I can do it, but will it be too much? ER it's easy. ER like nothing to be nothing to be done. Should I do ER as well? Should I do ER as well? Like, just give me 2 minutes. Or should I do ER as well? දැන් ළමයි දැන් ඉතින් මේ බලලා දැන් ඇඳට බලන්න. කියන බලන්න ඇඳට බලන්න. ඇඳට ගිහින් දැන් මේවා කරන්න යන්න එපා. Don't try to do this. Okay? ඇඳට ගිහින් නිදිගෙන මං කියන එක අහන්න. So go to the bed, okay? You go to the bed and yeah. ඇඳේ නිදිගෙන අහන් ඉන්නවා. ඒ කරන්න යන්න එපා දැන්. අහන් ඉන්න. Just hear what I say, okay? ඇඳේ ඉන්න ඇඳන් අහන් ඉන්නවා මොනවද කියන්නේ. Don't do it. No, don't do it. So person, go to the bed. Yeah, I'm not scolding him. Go to the bed. Headset tag කරම කර ගහගෙන කමක් නැද්ද? So once again, person had what? Have more. Okay, like once again, okay, there's a person. Look, once again, yeah, a person may have one or many cars. Okay, which means what? There are valuable material. Valuable what happens? There are what? There are two entities. Like you know how to represent it is a that person, and here we have what? Here we have cars. Okay, and I a person is identified by his personal identification number. Okay, like you can call it personal ID. Like you can simply write it as personal ID. Okay, and write it something like this personal ID. And yeah, personal ID and you underline it. Okay, underline it because you can uniquely identify it. And please, so like Lama, your paper marking teacher told me like if you don't underline the primary key, they won't give you marks like for the entire entity. For the entire entity, Lama, they won't give marks like if you don't like underline the name. I don't know like හැමෝම එහෙම කරනවා කියලා මම දන්නේ but a paper marking teacher told me okay. කරන්නත් බෑ නොකරන්නත් බෑ but so you on the safe side නේ. ආදර දෙන්න ඕනේ නැහැ. ඉරක් අඳින්න නේ. ඉරක් ඉඳ ලකුණු පහ දෙක තුනක් නැති කර ගන්න ඕනේ. ගොන් ආදර දෙන්න එපා. A person consists of what? A person yeah, a person has a name which consists of subname and initial, which means like it's a name is a what attribute lamine. Here the name is a composite attribute. And the name is categorized as what lamine? You can what categorize it as surname and the initials. Yeah, you can categorize as surname and initial. Superi. Each person has an address, okay. Which means yeah, we have an address as well. Nice. One person can own one or more cars, okay. One person may have one or more cars, okay. Which means like okay, they have given the relationship, okay. Yeah, I can write that owns. You can write owns. Yeah, person owns. Same you can write yeah. A person owns. One person owns what? One or many means it's one to many relationship. But there is only one owner per car, which means like but one owner will have. So yeah, one car will have only one owner. That kind of so it's one to many relationship. Nice. That's how you write the what? Relationship lemma. So always write the relationship from both side lemma. Then yeah, then simplify it. First of all, yeah, write the relationship from both sides. So what is it lemma? One person can have like it's obvious lemma. One person can have many cars, but one car can have only one owner. So it's what? So this side is one in. This side is one. So lemma, yeah. Then set off these things, yeah. Set off. M and one තියෙද්දි one කැපෙනවා 1 and 1 තිබුණේ තියෙන 1 කැපෙනවා ඉතින්. There's a bloody dog. මොකද සද්ද සද්ද කරනවා මේ රංගි. Next one. කෑ ගහනවා. අපි ගන් ඉනවද ළමයි? Also car has a what? Okay, car ID එකක් තියෙනවලු. And please underline it. Please underline it. Car ID. Car, okay, it has an year and a module. Interesting question, right? තාම ආතල් දීලා නැහැ. Okay, next one ළමයි. A report number is used to what? Identify accident. Okay. Also, every car accident has a what? Uh, has a every car accident has a location and date. One person can have one or more accidents, okay? Also, single accident can involve what? Many people. So once again, there is another what? Another table called what? Yeah, another table called car. Always, yeah, always remind me and try to what? Try to create entity names and attributes name which are available. What else? Like always try to use the entity names and attributes names which are available. What which are available in the scenario now. So is it very clear? Like always, like when creating ER diagram, always what try to use the words which are available in the scenario when naming entity names and attributes. Like, yeah, car accident, okay. And another method, they are like it's better what? It's better not to what? Not to keep spaces among attributes. Okay, like entities, of course, no problem. Like table එක නම් ප්‍රශ්න නැහැ, but even if it's table, okay, plus. එහෙම නිකන් හොඳයි ඉතින් like, on the safe side, but that's not an issue. But entities, of course, try to what? Try to create without spaces. And see, yeah, please what? Please be careful about the single and capital word as well. Like if it's car ID, yeah, C should be capital and ID should be capital. Okay, remaining things simple. And why each accident can be uniquely identified is what? Through a reporting number. No? So which means this becomes the primary key. It has a location and a date. You can write location, date. And what else are they telling? Also every car accident, okay, one person can have, okay, like once again, one person has what? Like obviously one person can what? Me now. But I mean, හැප්පුණත් එක්කම මේ ළඟදී. I got into an accident as well. Yeah, one person cannot. One person not can face many accidents. Yes, okay, nice. Oh yeah, like a එකපාරක් yeah, but I cannot. I can be subjected to another accident. Okay, that's practical. Nice. Also, one single, yeah, once again, like, yeah, yeah, in my accident also, like, there were like around two people were involved in the accident, which is like one accident involved what? Two persons. Yeah. So it's obviously one to many now, which makes it what? He also one and name can yeah, he also one capital and yeah, it's one to many relationship you indicated as what? M and M. M. So once again, why is it one-to-many relationship? Like from person side also, yeah. Like one person can have many accidents as well as one car accident can involve many persons. It's many to many. Interesting. Ivarane. Ane. It's over. I think note was like I thought note was a part of it. Yeah. Note use anything you no relevant one. Kiyela na please what. Now they are specifically used like yeah what specifically told it okay. Relevant words okay nice. Bro, yeah, okay. Revit extend the diagram, okay. By including damage amount. Lama, how to include the damage amount of each accident? Damage amount method because it's meant to be in a relationship like something like damage amount lama, it should be what put here lama. It's a descriptive attribute. Damage amount. Damage amount should be put like you can't put it here under person's lama like damage amount you can't put it under what? Person under the under like person under the amount like you cannot identify the damage amount separately. Like if you put what damage amount to person, what happens is like damage amount will be kind of biased. Like, for example, okay, let's put damage amount under car accident. එතකොට ළමයි what happens is like එක car accident එකකට කොච්චර damage එකක් වුණාද කියලා තමයි පෙන්නන්නේ. Each person ට කොච්චර damage එකක් වුණාද කියලා පෙන්නන්නේ. Yeah, so once again like if you put damage amount in car accident, they like once again this is car accident table. This is car accident table. So if you put damage amount on the car accident table, හොඳට අහගන්න. So once again I'm teaching all the practical thing. Like if you put damage amount on the car accident ළමයි, so this is car accident table. So that will indicate the total amount of like damage amount may of the car accident. Like once again, let's assume like there are three people involved in the car accident, and if you put damage amount here, like the total damage amount incurred to all the three parties will be available here. Like separately, the damage amount will not be available. So, but if you put it here, lamai, like what happens is like once again, me car accident separately you cannot identify the damage amount. Like the damage amount. received to one person for all the car accidents will be like obtained ළම like therefore example ගන්න මං accident 10ක් හැප්පුණා කියලා ඔය හැම accident එකේම damage amount එක ගන්න පුළුවන් like I cannot take the like I cannot take the total of all the damage amount but I cannot what if I want to obtain the damage incurred by one person in one car accident you should put it under here. So like what happens if you put it here what happens ළමයි when the total car like the I mean total damage amount given to all the people will be available. මෙතනට දැම්මොත් එමේ මොකක්ද? මෙතනට දැම්මොත් එමේ the total damage which is given like totally එක්කෙනෙක්ට හම්බෙන මුළු damage එක හම්බ like for example, if I'm facing five accidents the total like the damage amount will be the damage amount which is represented here ළමයි will be what? Will be a collection of all the five damages ළමයි. එහෙම නේ මට ඕන. Yeah. So like I want to know the damage one person is getting by facing one accident. So it's that means something it should be what? Included as a descriptive attribute. So simple. Descriptive attribute can attribute which is created to a relationship. Practical. This is what. Descriptive attribute. Or one or many one car or many one car or one car may be involved in one or many accidents. Okay. Also single accident can what? Involve many cars. So once again, yeah, මේව දාගන්න once again, yeah, meant to be in a relationship වෙනවා. When that is meant to be in a relationship, practical නෙමෙයි. Involve, yeah, we can write involves. So once again, like when it comes to a car accident ළමයි, කාර් දෙයක් කැප්පෙන්න පුළුවන් එකපාරයි. ඒක මොකක්ද? So once again, from car accidents point of view, yeah, in one accident ළමයි, there could be like plenty of cars involved in it. As well as like one car can accident plenty of time. It's obvious. And මොකක්ද කියවනේ? It's once again meant to be. Okay, like it's meant to be, yeah. One side in, one side in. It's interesting. I know this kind of it's very practical. It's nice, right? Like, is it very clear? Aren't it? Good, right? All good and all good. Isn't that question like interesting? It is interesting. Aren't clear? Why did you put it down? So, because like because Mount को में spaces create करने का it's not suitable. Okay, it's not suitable to create like it's not like when you are writing EL diagrams or is naming space दान I think होता है but table names වලට ප්‍රශ්නයක් නෑ but yes attributes obviously no spaces okay no spaces in between attributes it's better not to have put spaces in between attributes හරි are we done yes අද ළමයි පොදු right super that one is also done yes struggle කියන්න so me nada obvious yeah you can do the what you can do the මොනවාද logic gates ළමයි logic gates of course it's a piece of cake නේ like inputs ටික ගත්තා ලිව්වා then yeah scenario එක දැම්මා අන්තිමට yeah create the circuit using NAND gates or NOR gates or whatever it is so that yeah that simply yeah that's how you should do what logic gates thing then kids that's all today's session yeah I hope today's session was very productive effective and all those things so agent are you writing ALS this time huh? The unknown නැද්ද so once again here they have given that agent diagram as well even the agent diagram is very simple now additional yeah agent diagram එක තියෙනවා බෝල බෝල වගේ අඳින්න තියෙන්නේ බෝල බෝල වගේ අඳින්න තියෙන්නේ බෝලයක් in agents වලට agents නම් දාලා එයාලගේ functions ටික දාන්න that's how we create what an agent diagram මේ simple දේවල් for example maybe like user what yeah user communicates with agent one like okay like the agent diagram like here user communicates with agent one which means like you do a bloody user here do a bloody user so once again I'm creating an agent diagram and it's interacting what communicates with Bola Kanin agent one okay agent one agent A and yeah agent A is a chatbot agent okay you can write what you can just directly write yes chatbot agent that's better chatbot agent and දාන්න ළඟම මම questions දෙනවා අනිත් පැත්ත reply මෙහා දෙනවා. හරි. Agent A provides the service Y, okay. An agent provides service X, okay. Who the hell is that agent? Yeah, facilitating agent is an agent who communicates with, okay. Like guys, what method facilitating agent will do what? A facilitating agent at some point after the communication has taken between use an agent. Agent A requests the service X and yeah, sends the message to okay, like made a service X, you know, request service X and යාට ආපස්සට දෙන්නේ service Y එකනේ. දාන්න service Y එක. අනිත් පැත්තට දෙන්නේ service Y එක. Then what happens? Facilitating agent forwards the request sent by agent A to agent B. Okay, like there's an agent B. Then once again request එක. agent B ට දෙනවා. A request. Then agent B provide what? A response or a simple. To facilitator and the facilitator forwards what the response to agent A. Okay, agent A and agent A communicates with the user. Nice. How long? Isn't it easy and you cannot put it inside a nice bracket. This is what this is an agent system. Simple. User ask a query from chatbot agent. Chatbot agent request the service from service X from facilitating agent. Facilitating agent puts that to agent B. Agent B respond. It does respond to respond to simple, right? Isn't it simple? Isn't it simple? Yeah, that's done. Agent thing is done. Simple. So for agent is always නෑ ඔයාට ඕන නම් නේද මලක් හරි දාන්න ප්‍රශ්නයක් නෑ. The agent should be always drawing a circle. මලක් හරි දාන්න. Triangle එකක් කර දාන්න. If not, yeah, rectangle, square, parallelogram කැමති එකක් දාගන්න. Circle is not essential, but usually like we draw it using a circle. It's not compass. Interesting. You guys might be scolding me, right? මේම කරේ නැත්තම් බල ඉන්දිරය යනවා. හරි. So hope yeah, e-commerce thing also it's easy නේ ළමයි. So like what type of business model කියලා බලන්න එක මෙයා තියෙන business to මොකක්ද කියලා බලන්න. මාලා furniture ඉත අනිවාර්යෙන් ළමයි it sells furnitures to customers නේ. So once again what is the what? E-commerce first of all they asking what ළමයි? Nice. ළමයි first of all they asking e-commerce business type, right? Yeah, there might be Arduino. Yes, there might be Arduino තියෙන්න පුළුවන් like inside this like e-commerce thing. Yeah, Arduino might be available. So once again, what happens? Like, okay, I need to teach this. I need to teach this. So once again, now when it comes to e-commerce, I need to teach this. Sorry, I need to teach this. Now, when it comes to e-commerce, now we have what e-commerce. When it comes to e-commerce, we have something called what? මොකද මතක තියාගන්න ළමයි when it comes to e-commerce, we have what? Something called e-commerce business type. E-commerce like you have a business type. Whereas like you have e-commerce transaction type. Okay, you can have e-commerce business type. And next one you have something called e-commerce business model. E-commerce business model. Like even in our skill, like these two words are shitty words to me, okay? I fucking hate sorry, I'm fresh here. Hate these two words, okay? Man කැමතිම නෑ මේ. So once again what? E-commerce business types can what? E-commerce business types can it's what? B2, yeah, it's B2C, B2C. It's what? It's B2C, it's C2C, something like that. So in other words, Lamai, e-commerce business types can like are transaction types. Like the types of transactions. Model is none, it's what? It's pure click, it's pure click, it's pure what? Pure brick, it's brick and click. So please, Lamai, don't what? Don't confuse you, okay? So once again, kids, I'll what? I'll make it very quick. So once again, like when it comes to e-commerce, you have e-commerce business types. E-commerce business types, or else like e-commerce, you can call it transaction types. E-commerce are you can call it e-commerce transaction types. So e-commerce business types means like B2C, C2C, G2C, something like that. E-commerce what? E-commerce business model na e-commerce business model na pure click, pure brick and click, something like that. Uh, so once again, please note that down. So according to this analysis, Mala Furniture is what furniture store in your city, and it sells furniture to customer. What about the e-commerce business type, lamai? Business type is what? Business type is B2C, business to customer. And they're asking what is the business model did this business use before COVID-19? Of course, before COVID-19, like before COVID-19, pure brick and pure brick can conducting business activities only offline. Pure click now only online. Brick and click can both like online and offline. So obviously what? Due to COVID-19 epidemic, Yono started selling his products through online through his own web portal. In addition of selling customers who came to store. Obvious was that two words very clear? Like if it's on e-commerce business types, like if it's on e-commerce business types, so like you can call it what? E-commerce transaction types. If it's what e-commerce transaction types, or like if it's e-commerce business types, it's what it's like other transactions types. If it's like the models, like the business model, if they are what is the business model? If they ask what is the business model, it's pure click, pure brick or click. Was it very clear? Please don't confuse that part, okay? It's e-commerce business type or e-commerce business e-commerce art. A transaction type gonna like the type of transaction. It's what B2C. Before COVID-19, pure brick, obviously after COVID-19, it's what la after COVID-19, within one of the Mala business has now decided to conduct only is business that is online. It becomes what? Brick and click. Simple. That is ඉතුරු ටික හිතලා ලියන්න බලන්න ඉතුරු ටික ප්‍රශ්නයක් නෑ. Yeah, ඉතුරු ටික ප්‍රශ්නයක් නෑ. And once again what happens right? And like like they are Mala Furniture is conducting a business with another what business called Neela Furniture. Then what is the business type? Transaction type again in a B2B, business to business. While in B2C, simple. Then what are the advantages? Like advantages. What are the revenue models? Can various methods of earning revenue. Like what are the two revenue models of Mala Lamai? Like first of all, she can use sales as a revenue. Like she can use the what web portal sell products. That's a sales as a revenue model, and she cannot advertise products. Like Anita ke products advertise on website, so that is what advertising as a revenue model. As well as she cannot allow other business to sell their products and obtain a subscription, which is what subscription as a revenue model. Mention two methods that could be used to make payments through online. Yeah. They can use for in online like through what? Through banking apps. What else? Through banking apps then through PayPal like through payment entities, through credit cards, debit cards, PayPal. Mention opportunity of using intelligent agent. Yeah, intelligent agent can like what are the advantages of agents? Able to understand customer behavior, able to understand the customer like taste, and able to introduce product service to the customers, blah blah blah. Oh la la, e-commerce එක අතාරේ. හරි. ආයෙනම් මුකුත් කියන්න එපා මොකද e-commerce උත් හරි, okay? Then ළමයි ඇත්තටම හරිනේ. Good, right? We are done with lots of things ළමයි. මම මෙච්චර කරන්න කියලා හිතුවේ නෑ like I did it. Yeah, this networking thing ඔක්කොම බලා ගන්න ළමයි. Yeah, look at what these networking thing as well. මේ ඔක්කොම අතරයි පොඩ්ඩක් හෙට උදේ එක්සෑම් යන්න කලින් පොඩ්ඩක් උඩින් බලා ගන්න. So once again now here what happened is like me. Here we are converting what into a list. A list එකට convert කරනවා. Fruits කියන එක list එකට convert කරනවා. Then kids, that's all for today's session. God bless you. And as day අපි ගියා. I'll upload the recording as well. And bye bye.